All right, guys. So welcome to your workshop. We're going to begin looking at relation and function questions. This is the Jan 2016 paper, right? I'm going to do the solutions and you guys could follow along. I will ask at different points for input. So please feel free to, you could use your mic, you could use your chatbot. At other times, you could use the raise hand or the thumbs up emoji as well too, right? So first one, the diagram below shows the graph of 3 lines and a shaded region S, right? So this region here with the crisscross stuff on it, that's that region that they're talking about here, region S, right? So region S that they're referring to is inside of here, right? So it's defined by 3 inequalities associated with these lines. The inequality associated with the line Y, right, which is this line here, is Y is greater than or equal to 3, right? So we can clearly see that in this region that I've just highlighted in blue, Y is greater than or equal to 3. So it starts at the line 3 and it moves upwards, it's greater than 3, right? Let's see what else they want us to do. State the other 2 inequalities which define the shaded region. So this shaded region is enclosed by this line here, and this line here. For this line, right, just like Y is greater than or equal to 3, we will say that X is greater than or equal to 2. Because if we look at this line here, right, this is where 2 is. This region is going this way. It is greater than, X is greater than or equal to 2. If everybody understands that, just give me a thumbs up. Everybody okay with that? Yeah? Nice. So far, that's one of the inequalities that defines the shaded region. And the other one, X plus Y is equal to 10. Greater than would imply this way, but it is not greater than. It is actually less than this way, this direction. So the other inequality is going to be X plus Y is less than or equal to 10. More thumbs up if you're okay with that too. Right? So that's it for 2 marks, easy, right? The function P is equal to 5x plus 2y minus 3. And that satisfies the solution set represented by the closed triangular region. We've seen that closed triangular region here. Identify pairs of x and y values. X and y values here, right, is suggesting that we're talking about coordinates for which P has maximum or minimum values, right? So maximum and minimum values, we'll talk about, like, when we say maximum values, we're talking about the highest point or the highest peak. Minimum values would be the lowest point or the lowest peak. And if I was to come on the graph and identify coordinates or points where that is happening, right? Let me just take off some of these things that I scribbled on here, right? We could say that this is a point here, that's a minimum peak. Here's another minimum peak, and here's a maximum peak. So these are points that are the highest or lowest regions. It's like the outermost boundaries of that shaded region, of that triangular region that they're mentioning. So let's identify these points. So this point here, if I come down on my x-axis, that's the point 2. And across on my y, this is the point 3. So this point is our first point. It's a minimum point, and it's a point 2, 3. And then if you look at this point here, this is in line. If I come down here, bam, 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 to here, whoops, that's the point 7. So that means my x value here is 7, and it's still in line with this 3 here. So that's another minimum point 7, 3. Right? And then the last one up here that we didn't identify is at this point here, right? This is in line with 2 on my x, and on my y, we are in line with 8. So that's the other point. So those are the boundaries, if you want to call it that, right? Or the minimum or maximum points or values that enclose the triangular region. Again, for another 2 marks, right? So you see, at first glance at this question, it looks intimidating, but we really haven't done anything Like, we didn't even add, subtract, multiply. And that's 4 marks already. Okay? All right. So which pair of values makes P a maximum? Justify answer. Now we could look at this and we could say, well, oops, up one. We could look at this and we could say, well, the maximum had to be 28. I mean, I already identified that as being the maximum. But they ask us to justify the answer. So what we're going to do is we're going to take P. They give us P to be 5x plus 2y minus 3. And we are going to use each of these points at 2, 3, at 7, 3, and at 2, 8. Now we know that these are all coordinates and it provides for us x and y values, right? So this is the value. This could be this could replace x inside of the equation. P is equal to 5x plus 2y minus 3. We can replace x and y with 2 and 3 here, 7 and 3 there, 2 and 8 here. Yes, everybody agrees with that. Thumbs up if you agree. Right, somebody's joining in. Right, so everybody agrees with that. Excellent. Right, welcome, Ryan. So we just started, so you just follow along, right? So what I'm going to do is I'm going to take this P, and anywhere I have x, I'm going to replace it with, for this one, it's going to be replaced with 2, y is going to be replaced with 3, and I'm going to work out my value of P. And obviously the one with the highest value is going to be, the one that makes P maximum, right? So 5 2s are 10, 2 by 3 is 6, minus 3. That's going to give us 16 minus 3, right? That's going to give us, let's see if I could just move this piece here, add it up. Right, so P 16 minus 3 is going to give us 13. So next we have here 5x plus 2y minus 3. P is equal to 5 by 7 plus 2 by 3 minus 3. So P is going to be 21, 6, 3. 21 plus 6 is going to give us 27 minus 3. P is going to be 24. Here we have P is equal to 5x plus 2y minus 3. P is equal to 5 by 2 plus, someone wants to join. 1 second, let's let them in. Right, 2, 8 minus 3. So you're going to get 10 plus 16 minus 3. That's going to give us what? 26. There's my pen, right? Oops, just now, 1 second. Our mistake here. 5 7s are 35 plus 6 minus 3. 35 and 6 is going to give us 41. 41 minus 3 is going to give us what? 38. Well, didn't tell me anything there. It was our 5 2s are 10 plus 2 by 8 is 16 minus 3. 10 and 16 is 26 minus 3. That's going to give us 23, right? 10, 6, 16, take away 3 is 13, 5 sevens are 35, 2 threes are 6, 35 and 6 is 41, 41 take away 3 is 38, right? 10, 16, 26, 26 take away 3 is 23, right? So, where before we thought that this might have been the maximum value, P is maximum at 7.3 actually, since at 7.3, P is equal to 38. How am I identifying that? Well, after I've substituted the values inside of there, the largest or the maximum value of P occurs where? At 7.3, right? That's the largest value that we're going to get for P. P is 13 when we're looking at 2 and 3, and P is 23 when we're looking at 2 and 8, right? So the maximum value of P occurs at the 0.73. Is everybody okay with that? Give me a thumbs up if you agree with that. Yeah? All right, excellent. So everybody understand how we did that, yes? Good. So I'm moving on, right? So we have our functions question here now. Now, functions is basically substitution, right? I don't want you to be intimidated by any type of function question they bring, because this is essentially substitution. What you are substituting is the value that they put inside of this bracket here. If they put a pizza inside of here, then wherever you see an x in your function, you're going to put a pizza there. Whatever is inside of this bracket is going to replace the x. So, with that being said, g of negative a half means that we're taking negative a half and replacing this x here with negative a half, and then we are squaring that. And if we square this, we know to square something means basically multiplying it by itself, right? It's like repeated multiplication. A minus by minus is going to give us a plus. 1 by 1 is going to give us 1. 2 by 2 is going to give us 4. So g of negative a half is positive a quarter, right? Now, when they try to combine functions together, this is called what they call a composite function, right? Fancy word for just joining the two functions together. We just worked out what g of negative a half is, and we said that that is actually a quarter. So I could rewrite this to make more sense to me, right? G of a negative a half is a quarter. So if you're telling me to find f of g of negative a half, essentially you're already telling me to find f of a quarter. Make sense? And we're given f to be this up here. So wherever x is, I'm replacing that x with a quarter, right? That's what we said. So we're going to have 3 over 2 by a quarter plus 1. So what will that leave us with? We'll have 3 on top. 2 multiplied by a quarter. If you're not sure, just pull it out and go in your working column and work it out. That's going to give us a half. So we'll get a half plus 1, right? So we have a little more working to do there. So we need a little space. So move these things around a little bit. This is one thing I like about working on a virtual board, right? You can't do that on the board in school, right? Rub off everything and start over. Right. Yeah, I need a little more space there. So check me out now. I'm gonna end up with 3 over, well, 1 plus a half is 1.5, right? Now let's write this a little differently. I run out of space, right? So I'm gonna go to the side of it. I prefer if you write coming down in the exam. This is the same as saying 3 divided by 1.5, right? So 3 multiply, we have to change this to multiplication. 1.5 is actually 3 over 2, right? So we had to flip that fraction. So it becomes 2 over 3, right? We could cancel 1, 1, and guess what we're going to get? 2, right? So F, let's write it on the side here. F of G on negative a half is equal to 2. This is our answer. Everybody understand that? Let me see if I can just fit this in underneath here. Yeah? Right. So you see how easy these things are, right? I'll look a little better. Right? Always practice when you're doing these questions to write coming down the page. Somebody in the waiting room. Always practice writing down the page. Right? I had a maths teacher when I was in secondary school. His name was Mr. Khan. Mr. Khan used to be on real bad for that. God do it like that, you know, you gotta write over all that word. Mr. Khan put in a line through your book and start over. But it makes sense too, right? Because I'll tell you why. When I don't know if you're familiar with how, well, maybe not, but when you're correcting papers for CXC, what they do is they split up the paper, right? So if you get assigned to be an examiner or a marker in CXC, you get assigned to a table. And on that table, you might be correcting one question. So let's say I get put on a table and we might just be correcting this relations and functions question alone over and over and over and over for all the papers, right? Now, when you have that volume of papers to correct, it's be difficult as an examiner when you have to try and find the answer or try to fight up. You know, some people will write their work and a piece of work in here, a piece of work in so, and working all over the place. And you as the examiner now trying to follow the trend that's happening on the paper there. After a while, examiners will get frustrated and they will just either give you the bare minimum. If they could find something here, they put a mark there, a mark there, and you lose out. But when your work laid out like this, examiners feel obliged. They feel, a bit more compelled to go through and correct. And even if it is you make a mistake somewhere, because the work is laid out so nicely and they can follow your thinking, even if you don't get full marks, you might be able to obtain the maximum amount, right? So it's important for you to lay out your work in a nice, presentable way. All right, next one. The inverse of a function, the one that everybody is struggling with. The problem with this is because plenty of people have challenges with changing the subject of a formula. That's really why it is people struggle with this. Because the steps is very straightforward, right? The first step is to replace, and I'll write all the steps here, right? You don't need to do this when you're doing your solution. Replace f of x with y. So it becomes y is equal to 3 over 2x plus 1. Then my next step is going to be interchange x and y. Right? So wherever I have y, I'm going to put a x. Wherever I have x, I'm going to put a y. Then I'm going to make y the subject. Now to make y the subject here, what I'm going to have to do, I'm going to just rewrite it, right? So we'd see the full steps involved. Hey, hey, hey! Is you're going to carry this across the equal sign. So since we're dividing by 2y plus 1 here, when I carry it across, I have to multiply, right? I'll expand this bracket now. So I get 2xy plus 1. And remember, we want to make y the subject, right? So the easiest thing to to move is going to be this 1, carrying this across here, so it becomes -1. And then lastly, I want y. So I move this 2x from here. Now 2x being multiplied by y. So when I carry it across, I'll get 3 minus 1. Well, we could work out that, right? 3 minus 1 is 2 over 2x. And we could cancel the 2 here. Now if you had something like 2 plus, I don't know, x over 2x here, you cannot cancel like this, right? It doesn't work like that, because this entire thing is considered to be a term. So you can't cancel one thing in the two. If you cancel, then it have to have like 2 multiples of 2 that you could cancel like that there. All right, so always bear that in mind. All right, so here we could cancel because it's just a 2 here on top. So that would leave us with 1 over x. So we could write that our f inverse of x is equal to 1 over x. Yeah, everybody okay with that? Give me a thumbs up if you're good with that. Wait, we have a problem. We have a big problem. This is the problem here. It's exactly like what I was now saying. I was saying, well, why will it be 1 over x? It can't be 1 over x. That's too simple. That's the problem here. X by 2y and x by 1. We're going to get 2xy and we're going to get what here? X, not a 1. So when we carry this across, this becomes 2xy is equal to 3 minus x. Yeah? And then when we move this from here, we're going to get 3 minus x divided by 2x. That is our inverse of the function. Right? So it's important to check over your work. Right? Always look back, just make a run through. Do not assume that, all right, I know this topic, so I'm going to just do it and move on to the other question. You always look back. All right? So everybody see that x, when you expand in the brackets, you have to multiply by both terms. X by 2y is going to be 2xy. X by 1 is going to give me x, not 1. And when you carry the x across, you're going to get negative x. So you get 3 minus x. And then last, we're going to move this 2x from there. So we get 3 minus x over 2x. So this is our inverse here. Cool. Now we can put a thumbs up. All right, everybody right to that one, yes? All right, good. So we're moving on. So this full question here, part A and part B, was from our Jan 2016 paper. All right. For those of you that join us so late, I broke up the I have 3 notebooks set up here. I have one for relations and functions, one for measurement, geometry, and trigonometry, one for vectors and matrices. So currently we are doing the relations and functions questions, right? But we will rotate between both of them. So I plan to do about 3 or 4 function questions. Then we go look at some geometry questions, and we come back and keep circling back like that. All right. So that was we just finished our Jan 2017 question. We're gonna look at June. Sorry, that's Jan 2016. This is June 2016 now. Right? So we have the functions. F of x and g of x are defined as f of x being 2x minus 7, g of x being x squared plus 1. Write an expression in terms of x for each of the following. So seeing that I just did the inverse of a function, right? I'm just going to write the steps here. Right, first let f of x or g of x be equal to y. The second step is to interchange x's and y's. The third step is to make y the subject. Can you guys attempt for me the inverse of f of x and the inverse of g of x? Is everybody comfortable enough to try that? Just raise your hand if you think you could give it a try. Everybody, right? Idel, Tony, Terrell, Rian. Yeah. Jasmine, you're good, right? Nice. Salima, you right? All right, cool. All right, so you all are gonna try to do the inverse for f of x to me, inverse of g of x, and then I'm going to do the solution for it. All right? So you try and do it for me, and then we correct together. All right, so let's continue with our correction for this. So the first one, let me just make sure I give myself enough space here. Open it up a bit one time. Right, there you go. So this would be a little easier than the question we had before, because there's no numerator and denominator part. So we have 2x minus 7. We say replace the f of x with a y. Then we're going to interchange x's and y's. Then we're going to make y the subject. So I'm moving the 7 across. So this fella going across here, it become positive 7. Then we're moving this 2. So we're going to get x plus 7 divided by 2. Y. So f inverse of x is equal to x plus 7 over 2. Just raise your hand for me if you got that. Yeah. Good job. Excellent. Well done. Tony, you got that? Yasmin? Carol? You guys okay with that, right? I'm going on to the other one. G of x is equal to x squared plus 1. Right? So we're replacing this with a y. We're going to interchange values with x's and y's. Then we're going to make y the subject. So we're moving this 1 first. So we're going to get x minus 1. And then we have to move the square, right? So when we move the square across the equal sign, it becomes the square root. Right? So g inverse of x is equal to the square root of x minus 1. All right, give me a hands up if you got that. Thumbs up. Everybody good with that, right? Rian, Solana, Jasmine, Chimari, Idel, you good? Nice. No, sir. What happened there, Solana? What tie up? The square. You only square the x. You square the x alone.
Yes, sir.
Yeah, now you have the square. So you have to understand something, right? When we move in something across the equal sign, if we move and you see that's the risk we teachers take when we tell you about move something across the equal sign, right? Because this is not Harry Potter, right? You just can't move things across the equal sign. That's really not what happens in mathematics. To go from this line to this line, what you're doing is you're actually finding the square root of both sides. And the square root of square is going to actually, these two things are going to cancel each other out. And this is how we get to this line here. Right? But sometimes telling students that, you might do it in Form 1 and 2 when you're not teaching the topic. Later on, you'll just tell them, just move the square across the equal sign or move the entire term, right? You divide by 2. Move it across, it will divide because it's multiplying before. But you're actually doing the same operation on both sides, and that's what's causing it to seem as though it's moving across. the equal sign. So what is missing in between here is that we are finding the square root of both sides. The entire side we are finding the square root of. So when I say move the square across the equal sign, you have to treat this entire thing as a term. And you'll find the square root of the entire thing. Understand?
Yes, sir.
All right, cool. You forget, all right, especially when we change any subject of our formula. Right. Next one. Now, if you do have a number in here and you're doing a composite function, then the answer is going to be an expression, right? So remember I told you guys that with functions, it's basically substitution. So we have f of x is, what was f of x again? 2x minus 7, 2x minus 7. And g of x is x squared plus 1. So if I want to find f or g of x, I am really replacing this entire g of x here. What I'm really trying to find is f of x squared plus 1. Because g of x is this, right? Agree? So it means, therefore, that I am going to replace this x here with x squared plus 1. So what I will get is 2x squared. Remember the mistake I make earlier? You don't make the same mistake twice. 2 by x squared will give us 2x squared, and 2 by 1 will give us 2 minus 7. So we get 2x squared plus 2 minus 7 will give us minus 5. Sorry about that. Right, so this is our f or g of x. Notice is an expression. It's not, there's no numbers in there already because we're actually replacing this f of x here with g of x. And g of x is given as x squared plus 1. So we're finding basically f of x squared plus 1. Right? Just give me a little thumbs up if you understand now. Right. Now they're trying to complicate things further to make your life difficult, but we have solutions for them things. Right? So check this out. We just work out what f or g of x is, right? F or g of x is equal to 2x squared minus 5. They want f or g inverse of x. So that basically that's this entire thing inverse. But we know how to find the inverse, right? The inverse, we simply say that y be equal to this. Then we're going to interchange x and y's. And then we're going to make y the subject. So I bring this across. Then I have to move the 2, right? So we're going to get, this is the same thing I was now telling you about, right, Solana? The whole thing here going to divide by 2. And then finally, the whole thing here going to be the square root. And find the square root of all of that. So this seemingly confusing thing here is really just the square root of x plus 5 over 2. Everybody right to that? Easy? Raise your hand if you think now is easy. Yeah? All right. So if I tell you h of x, f of h of x is equal to 4x squared plus 5. And I ask you to find f of h inverse of x. Can you do that for me? Raise your hands if you think you could do that. Yeah? 3 people raise their hand, so nobody else could do it? Yeah, man, only could do it. I'll even this one we just do on the side here. Try this to me and see if you can work it out. Right? Because unfortunately, you're not going to get to take me to the exam, right? You had to write the exam. So I had to make sure that you guys could do these things on your own without me. So try this one. It's the exact same steps that we did on the left. You're going to replicate on the right. So try that. All right, so let's correct it. So we want to find f of h inverse of x, right? So we say let y be equal to this. Then we're going to interchange, swap x's and y's. We move this 5 across. Then we move the 4. Then we move the square. So f of h inverse is going to be the square root of x minus 5 over 4. Right? Give me a thumbs up if you got that as your answer. Right. Good. Last part of the question now. For 3 marks, they want us to show that the f inverse of, so we need something strong up here, right? I'm just gonna cut them out. We need this. I just put them on the side here for now. We need this. Right. And we also need this. Somebody is joining on. Good. So we need these 3 things here. So they're basically saying to show that f of g inverse of 5 is equal to g inverse of f inverse of 5. That's plenty things to consume in one go. So basically you're taking your this one, which is f of g inverse, and you want to put 5 inside of where we have the x's here. So this is what f of g inverse of x is, right? So if we say a 5, then we're going to put 5 plus 5 over 2, which is going to be 10 over 2. And for now, I'm just going to leave this as the root of 5, right? On the opposite side now, we want to do g inverse f inverse of 5. Now, when you have composite functions like this, you want to work from the right going to the left. So I want to figure out what f inverse of 5 is first, and then I'll put the answer I get for that inside of g inverse of x, right? So let's do that. Let's find f inverse of 5 on the side here first. Right, so f inverse of 5 is going to be 5 plus 7 over 2, right? Because whatever we put in the bracket is going to replace the x. So 5 plus 7 is 12 over 2. I'm going to get 6. So f inverse of 5 is 6. Right? I'm going to draw that better. So they look like a minus 6. So g inverse f inverse of 5 is really g inverse of 6, right? Because we just work out f inverse of 5. And g inverse is this here. So what we'll get is the square root of 6 minus 1. We're replacing the x with 6, which is also going to give us the root of 5. So we have this being the root of 5 and that being the root of 5. So we just show that, therefore, f of g inverse of 5 is equal to g inverse f inverse of 5, which is equal to the root of 5. Right? Across on the side here is all working, right? Working. These are our formulas here. Here we find in F inverse of 5. Just give me a thumbs up if you understood that. Anybody need me to go it over again? If you need me to go it over again, get my hands up. Cool. So let's go over again, right? So I'm just gonna rub these things off. We're going to just rub it off on this side. Now, in order for us to show that this is equal to this, we need to work it out. And if the answers we get for both of them is the same, then that satisfies the property that they are equal to each other, right? So just raise your hand if you understand that. Good. So on one side, we're going to work out what f of g inverse of 5 is. And then on this side, we're going to work out what g inverse of f inverse of 5 is. Now, on this side, you want to work out this part first so that you can replace this with a number instead. Now make life a lot easier, right? So this is what we did. We worked out what f inverse of 5 was by substituting 5 inside of here for the x, right? And 5 plus 7 is 12. 12 divided by 2 is 6. So just give my hands up if you understand that. Yeah? Right. So we know that f inverse of 5 is 6, right? Now, if we want to find g inverse of 6, it means that we're going to replace this x here with a 6. So what I'll get is the square root of 6 minus 1, right? Because we're not doing x here anymore, we're doing a 6. And that will give us 6 minus 1 will give us 5. So g inverse of 6 is 5. So we want to work out on this side now to see if we will get the same answer here, the root of 5. So let's check it. Now we know that f of g inverse of x is x plus 5 over 2, square root of all of that. So if I want f of g inverse of 5, it means that wherever I have that x, I'm going to put a 5. And what that's going to do is going to give me 5 plus 5 is 10 divided by 2. And then 10 divided by 2 is 5. So we have just shown that we will get the same answer for both of them. And that's going to prove that they are equal. Same answer. See it? So since the answers are the same, then they are equal. So we could write that f of g inverse of 5 is equal to g inverse or f inverse of 5, which is equal to the answer that we worked out, which is the root of 5. So thumbs up now if everybody understands. Right? Everybody? Jamari good? Kirali good? Tony, Brittany, Shaniqua, Brianna, Avalon, you okay with that? Right. Everybody good, right? Tony, you good, right? Yeah? Okay. Kirel, you all right? You good with that? All right, nice. Perfect. Cool. So we're going away from the functions a little bit. Part B was this is what we call a distance time graph. You could tell by one axis time, that thing's in kilometers distance, and the other one in hours, time of the day. Right? So these don't be too bad. These type of questions. Most of the time you can just read everything off the graph. State the time of the day at which the car arrived at town C. Right? So the car arrived at town C. This is town C here. This is when I get there. And all we need to do is come all the way down, bam, 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 and figure out what time that is. So if you look at this, between each hour, it's broken up into 4 parts, kind of like our clock. So this had to be 8:15, 8:30, 45, and then it go to 9 o'clock. So this time here has to be 8:30. And it's AM, right? Because we're seeing 0600 hours, 0700, 0800, 0900. So that's 24-hour time, right? So this is in the morning, right? If it was nighttime, it would be 2000 hours. Calculate the total time in minutes. That's an important part here. For which the car stopped during the entire journey. Now, we know that speed is equal to distance over time. So as speed increases or as we drive, you're seeing that the length of time that they are, or the distance that they are covering is increasing as time passes by. But then there are certain points on the graph where, if you look, they remain at the same distance. They haven't moved, but time has passed, right? So we cover 40 kilometers, but between 7 o'clock to 7:30, there was no movement. So that means that they're at rest. They're not moving. Then up here between 8:30 to 8:45, they're also at rest. They're not moving. Agreed? So those are times where the car stopped during the journey. So we could write that. We could say the car stopped. First stop was between 7 to, this is 7:30, we said, right? And they want it in minutes. So that's equal to 30 minutes. And then the second stop, they stop at 8 o'clock. That was at Tom C, right? No, not at 8, at 8:30. Right, they stop at 8:30 until this is 8:45. So that's 15 minutes. So in total, that's 45 minutes. That's total time. Two marks. Right? Now, you notice that I was set a 2 mark and 1 mark and 3 mark question, right? The compounding effect of these 2 mark and 1 mark questions is very significant. You cannot underestimate these questions in an exam. Even if it is, you cannot work out the more complicated type of questions, right? Like this one for 3 and some of the others. You would be surprised every time you skim on 1 mark or 2 mark or 3 mark question off. Over time, it's going to build up. You will do yourself a greater detriment if you leave out these 1 mark and 2 mark questions. Don't ever leave those out, right? That's what's going to make or break you in any of your exam, not only math, even in the other subject areas, business, accounts, biology, chemistry, physics, it doesn't matter. Do not give away those 1 mark and 2 mark questions, right? I had a teacher and they had a policy. Do not hand up any paper without an answer. She don't care if you write utter garbage, but she didn't care if you write utter garbage. She'd be upset. But get the point to I saying. Don't leave it out. because you might be able to get a half mark there or 1 mark out of a 3 mark or 2 mark question. And over a period of time of doing that, they add up. You don't give away the marks. Do not ever, 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 ever give CXC back the marks. Take all, don't leave anything on the table. All right, so don't leave out anything. Even if you look at a question and it look confusing and you mightn't be utterly, I wouldn't say sure. Sometimes we're just not confident in our answer. You know, sometimes you second guess yourself. Raise your hand if you second guess yourself sometimes. Right? Don't second guess yourself. Most of the time, you actually on the right track. And even if it mightn't follow all the way through to the end, there may be some things along the way where the examiners say, you know what? I like the direction they was going. I like how they was thinking. They may not have gotten the correct answer, but the direction or the journey they was going in, this is the correct journey, right? Because on TikTok, a lot of people keep asking, so how much to get 3, how much to get 2? And that's been a difficult question for me to answer, right? Because CXC doesn't really mark. Yes, they look at the marks, but they look at those profiles that the teachers keep talking about: knowledge, understanding, comprehension, computation. They look at those things in order to assign marks, right? And you could earn these marks, right, based on, you could only earn those marks based on attempting the question. If you do attempt the questions, then you just leave any marks on the table. So don't leave them on the table. Despite how the question might look, sometimes after you get in the question and start working it out, you realize, but wait now, this not so bad. Initially looking at this, you might say, oh Lord, look at that graph there. I don't know how to do nothing with that. And then when you watch this, they just ask you what time of the day the car arrived at Tongsi. You could just look at the graph and see when it arrived at Tongsi. That's 1 mark there, right? Calculate the total time when the car stopped. Well, obviously the car ain't moving here, right? We didn't do anything there at all. We subtract that you learn in primary school, and then you add 30 minutes and 50 minutes. And that's 3 marks right there, right? Determine the constant speed of the car during stage 2 of the journey. So this is stage 2, right? Again, another thing I was teaching some of my students, I think this was in what boy? One of them other subjects might have been accounts or business or something. I think it was business. Sometimes you need to eliminate the, like one of my other lecturers used to say, they cut out all the fluff. Questions just have a lot of fluff. All you really need is this part here, the constant speed. Constant speed, we don't even need constant. Determine the speed, right? Determine the speed of the car, right? Well, during stage 2 is important, but I just think about the speed. Speed, as you know it, speed is equal to distance over time. That's what we need to calculate speed. So if we go to stage 2 of our journey, all we need to identify is the distance traveled. I'll spend distance here, right? And the time taken to travel that distance. That's all we need in order to work out what speed is. Distance over time. Make sense, eh? That's what we teach us as BA4, to make sense of these things. So we start at 7:30 and we go into 8:30 here. Agreed? Everybody agree with that? Look my hair to here. This is 7:30 and I go to 8:30. So check that. The time is an hour. 1 hour. So that even make it better because now you're going to be dividing by 1. Right? See how easy this question is, right? And then if we go across on this side now, this is the distance here, and this is the distance here. So what I mean, when we were at this point here, when we start stage 2 journey, we was at 40 kilometers, and then from 40 we went to 100. So what's the difference? The difference between those two will tell you the distance traveled for that part of the journey. Makes sense, right? It'll be 100 minus 40, which is 60. So the distance traveled was 60 kilometers. and the time taken was an hour. You know, I always used to remember this. I always used to think about the speedometer in my mother car. It's in kilometers per hour. This kilometers per hour, if you write this differently, is the same distance over time. So the speed, the constant speed is 60 km per hour for 2 marks. See, this is our section 2 question. And we now eat up this first part, second part, third part. Right? We already make 5 marks off for this question. Right. Average. Average speed. Calculate the average speed of the car. So we're going back to speed again. So we had to work out the speed. But then average, when you think about average, if I tell you calculate the average mark in a class, right? Let's just say it's a small class. So you have 5 marks. A man get 15 out of 20. A girl get 18. An next I get 16. Somebody get 19. And somebody get 20. They're all bright in that class. The average should be found by adding up all of the marks and dividing by the total number. Raise your hand if you agree with that. Everybody agree with that's how you find the average, right? And to find the average mark in the class, it's 5 people in the class. I add up all 5 marks and I divide by 5. Now everybody agree? I only see 4 people raise their hand. Raise your hand if you agree. Average mark in our class. Add up all of the marks and I divide by 5. Good. So if we go to our journey now, check this out, right? We have, let me take off some of these things, right? Let's look at where we could find the average speed of different parts of the journey. Right? We have this part of the journey here. Could find average speed here. We just work out this one. That was 60. And then let's have this one here. And they actually highlighted for us. They tell us 3 stages. So let us find the average speed of each of these. Let us find the speed of each stage. So that will be equivalent to like the mark in the class, 3 marks in the class. And then we could add up the 3 marks in the class to find the average mark. Give me a thumbs up if you understand what it is you're going to do there. So we are stage 1. That will come like a mark, 1 student mark in the class. Stage 2, that is our next student mark in the class. And stage 3, that is another mark. And then what we're going to do is add the marks up and then divide by 3. So stage 1, what we did just now, when we know stage 2, we work out stage 2 above, right? Stage 2 was 60 over 1. Speed was 60 km per hour. Right? And that was because we do speed is equal to distance over time. So let us check stage 1 distance and time. So stage 1 distance was 0 to 40. So that was easy because they start from 0. So that's 40 kilometers. And let me check the time now. The time was 6 o'clock to 7 o'clock. Another hour again. 1. So the speed is equal to 40 km over 1 hour. So the speed of stage 1 was 40 kilometers per hour. Right? Stage 3 now. Stage 3, we was at 100 kilometers here. And then we went back down to 0. Right? So like they returning, they reach to wherever they need to go and then they go back now to tongue A. Right? You see, they went to tongue C and then back to tongue A. So that's 100 kilometers in all. Is the distance that they're going to travel to go back. And I check the time now. The time was 9 o'clock. No, not 9. 8:45 here. 8:45 to 10. Right now, we have to do a little check in there, right? 8:45 to 9. is 15 minutes. I like to use our timeline for things like this to work out time. That's just my preference, right? Because I could visually see it on the line and then it's easier for me to work out time. Then 9 to 10, that's where we're going to, right? We're stopping at 10. That's our hour. So this is a 1.25 hour, right? Everybody okay with that? Right, 8:45 to 10. So speed is equal to 100 over, now just put it as 1.25, right? Now you could use a calculator for this paper, so just plug that in on your calculator for the sake of that will work out to be 80 km per hour. So we now have, we now have three speeds. If we want the average speed now, average speed, just like how we find the average mark just now, you take 40 plus 60 plus 80, divide by 3. This is all in kilometers per hour. And that will give us 180 divided by 3, which is 3 into 18 is 60 km per hour. Yeah? Everybody okay with that? A thumbs up if you're okay with that. Nice. So 60 km per hour, that's our average speed. Cool? Okay, good. All right, so let's look at the other question. So what we do is we do this Jan 2017. What I want to do is I want to give you a little 5 minutes something every hour and a half, right? Because the brain could only consume for a certain amount of time. And we go into the tree, so we had to break it up. Plus, it's not healthy to sit down for the extended amount of time. So let us do this question. When we finish this question, this is the first question set that had for relations and functions. So we're doing good. It meant that we did 4 years, Jan and June 16, Jan and June 17. We do 4 years, well, not 4 years, 4 sittings. 4 sittings of section 2 relations and functions questions, right? So then you take a break, we go and look at the one a little like, which is the circle theorem, right? You go through all of those, then we hit vectors, and then we come back to relations and functions again. In the latter part of the evening, when everybody gets tired, we will do some multiple choice to kind of tone down the afternoon, right? All right, so let's go. The table below shows pairs of values of x and y, where y is inversely proportional to x. Now, there's two things that I needed to know here, right? We have y could be directly proportional to x. And when that happens, I want you to remember this formula, y is equal to kx. And in this case where we have y is inversely proportional, we will write y is equal to k over x. Now, in these type of questions, you will always have two values, or you will have a pair of values where you actually know what x and y is. You will use that pair of values in order to find out what k is in these formulas. Because the key is to be able to work out a formula that describes the relationship between x and y. These things that I wrote here is the way in which it is y and x is related. If they're directly proportional, then there's a number that is like a scalar or a multiple that tells you the amount of times x is or y is x amount of times of them. That sounds like a big point. Y is this amount of times of x, right? When it's inversely proportional, it's like x is one something of y. So I am going to say, since this is inversely proportional, since y is inversely proportional to x, then you always start these questions by stating this, right? So it can either be this one or this one. You have to read the question, right? Now the question could also say y is inversely proportional to x, or it could say y is inversely proportional to 3x. If they say 3x, then obviously you'll just put 3x there, right? Instead of x. Understand? So you have to be a little careful. They don't usually, I haven't seen them um done that in the CSEC maths, maybe in AdMaths or something, but not CSEC maths. Most of the time, it's just be y is either directly proportional or inversely proportional, but pay attention. If they do, write what they give you. Anyway, inversely proportional is y is equal to k over x. If or when x is equal to 3 and y is equal to 2, right, what we're going to get? We will then have run out of space. Y is 2. We don't know what k is yet, and x is 3, right? Bring this across, we're going to get k is equal to 6. I like how it's all over the place. So k 3. So y is equal to 6 over x, right? Because we now know what k is. Raise your hand if you understand that. Actually, this part was for underneath here. So it's the answer for here. Right? So the first part was first to write it like this: y is equal to k over x. Express y and x and y in terms of x on a constant k, as this part here, right? And then calculate the value of the constant k. We substitute x is equal to 3. We substitute the 2 and the 3 there for y and x, and we work out what k is. Right? So y is equal to 6 over x. Determine the values of a and b. Now that we know that y is equal to 6 over x, if we know one value, if we know what our y is, or we know what our x is, then we could work out what the corresponding value of x or y is. So this is what I mean. Right? We say finding a, right? Y is equal to 1.2. Then y is equal to 6 over x. If this is 1.2 x, over 6 sorry, right? So I replace the y with 1.2. Everything remains the same on this side. I want to find out what x is. The x is really the a, right? So I move the x across on this side, right? Because I can't do anything with the 6. It locked in because of that x underneath there. I'll get 1.2x is equal to 6. Then I could move this 1.2 across here. And I'll get 6 divided by 1.2. So x is equal to 6 divided by 1.2, 5. So a is equal to 5 when y is equal to 1.2. Is there any if you understand that? Everybody? Yeah? Okay. So I'm doing the B now, right? Finding B. So let's recap the steps. First, we need to know what is the value that we have. We have 20, x is 20. So when x is equal to 20 and we know that y is equal to 6 over x, then y is equal to 6 over 20. We can work that out. We go to our calculator and we get 6 divided by 20, that's 0.3, right? So B is 0.3, right? Because B is your value for y, your corresponding value for y when x is 20. Right? Give me a thumbs up if you're okay with that. Everybody good with that? Yeah? Avalon, Rian, Brittany, Jamari. Okay. Right. Part B. Fancy stuff now. Lucky thing about the graph, these graph questions is they've gotten a bit easier over the years, right? You're not required to actually go and create a table of values, although sometimes you might see questions like that and draw the graph and then pull out information. Sometimes, like in this paper, they gave you the graph and you have to use your knowledge of graphs in order to answer the question. Use the graph to solve the equation for x squared minus 6x plus 8 is equal to 0. So the curve is actually the line x squared. If we take x squared minus 6x plus 8 and we draw it on our graph, this is what it would look like. The curve itself is this equation. And we're saying that this equation is equal to 0. Basically, it's saying that it cuts the x-axis because the x-axis is the point at which y is equal to 0. So when you ask me to solve this equation, you are asking me for the points where the curve cuts the x-axis. That's what you're asking. And the curve cuts the x-axis at when x is equal to 2 and when x is equal to 4. How much people know that was so easy? They know that. Find it easy now, eh? Raise your hands if that easy. And it will do that if you see that in exams. That's it. Absolutely no working whatsoever. You just need to understand the properties of graphs and know that when a graph cuts the x-axis, we would usually write it as the equation of that graph is equal to 0 and the points at which the graph cuts the axis, the x values, right? Because what's the corresponding y value here right now? Anybody? At these points, y is what? Anybody knows the carry?
0.
Y is 0. These points, y is 0. Here you are saying that y is 0. Another way of looking at this is y is actually equal to x squared minus 6x plus 8. This is the equation of a curve. Y is equal to this. And y is equal to 0 means that x squared minus 6x plus 8 is also equal to 0. And that happens when x is 2 and x is 4. Everybody understand that? Raise your hand if you understand that. Yeah, no problem. Customer. Right. The curve, this line, well, it's not a line, it's a curve. The curve is defined, or you know, like how you'd say the equation of a line is y is equal to 2x plus 3, and that would describe like a line, right? That's on your graph, right? You okay with that, Shaniqua? Yeah, a curve also has an equation. The equation of this particular curve is x squared minus 6x plus 8. And if we draw it, this is what it would look like on a graph, exactly like this. Now, if I say, now there are points, every point on the curve have coordinates. So for example, this point here has the coordinate 1 and 3, right? This will be a 3 here. These points are the solution to my equation. If I say x squared minus 6x plus 8 is equal to 0, we just said that y is equal to this. So it means that I am replacing y with a 0. And if I replace y with a 0, you know, like when we solve a quadratic equation, we will find two values for x. Just give me a thumbs up, everybody, if you agree with our statement. A thumbs up if you agree that when we put a quadratic equation equal to 0, we could solve for x and usually we'll get two answers when you work it out. Everybody agree with that, eh? Everybody know how to solve quadratics, that makes sense, right? We could do it graphically as well. Putting it equal to 0 is looking for when y, because this here is y. You are saying here that this is equal to y, and then it's saying the same thing is equal to 0. When y is 0, what is the values of x? This line here, this x-axis here, is when y is equal to 0. Look, it's passing through 0 here. This is when y, this is 0 here. Y is 0. Any point on this line, any point that I circle on this line, y will always be 0. Understand that? Give me a thumbs up if you understand that. Right. So if the curve, which is this x squared minus 6x plus 8, that's your quadratic equation, touches and cuts the y, this axis here, when y is equal to 0 at 2 and 4, it means that when we substitute values for x as 2 and 4 into this equation, we will always get 0. Try that for me now. Take this equation and substitute 2 in it and tell me what to get. And then substitute 4 in it and tell me what to get. come here, just going to get some tissue here. No stuff. Substitute that for me. Come here now. Substitute 2 and 4 into the equation and tell me what you get here. Right. So when you substitute it, what again? 0, right? If you do 2 squared here minus 6 by 2 plus 8. That's 4 minus 12 plus 8. 4 minus 12 is minus 8 plus 8, 0. You all got that? So you see, when we substitute 2 inside of there, y becomes 0. Right? That's one solution for your equation. And if I do the same thing with 4 too, x squared minus 6x plus 8. You get 4 squared minus 6 by 4 plus 8. This is what? 16 minus 24. That's another 8 too. Minus 8 plus 8. 0. So when these two values are substituted into our equation, we will get y. This entire side here will end up being equal to the same 0 that we're talking about. Everybody all right to that? You all understand that now? Shaniqua, you good? Yeah? Everybody feel a little more comfortable with the graph and what these things mean now, right? So there's a connection. There's a connection between that topic you're doing algebra and these graphs that you're doing here now. They're not two isolated topics. They're the same. It's just that we teach them in parts. We will teach you how to solve a quadratic equation, but you could also draw the quadratic equation on a graph and solve it the same way. Right? Now, there's some other things that we could do to this with this graph too, right? With this graph, there's a range of values of x and y that will fit this equation. It means that for every point on the graph, and there are infinite points on this graph, right, it will continue to adhere to this. This is why we call it relations and functions. To this function, it is a point on the graph. But there's a minimum or sometimes a maximum point, right? Because what happens with the graph, especially when the coefficient of this x squared here is positive, right? This is a positive 1 in front of this x squared. Once it is positive, the graph takes this particular shape. It's like if you put two eyes here and you draw a circle around it, it looks like a smiley face, right? You have this U-shaped type of graph. It doesn't matter what I put here. It could be 2x squared plus 3x minus 4. Now I'm making this up, but I just saying. Once it is in this particular form where this is positive, it could even be 343x squared plus 500 and something x minus 1,000. Now, I'm not saying that this is accurate, right? But the point I'm making is that once this is positive, once these values are positive, the shape of the graph remains pretty much the same. It is a U-shaped graph that if we draw some eyes and a circle around it, it would look like a smiley face. What does that mean for us? It means that the graph has a minimum point. It reaches a minimum point, which is the lowest point that the graph could reach to, and then it changes direction. What do I mean by change direction? All the time the graph going down here, bang, 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 it's going downwards. And as it reached to this point here, what is this point? This point is 3 on my x and -1 on my y. That is the lowest, or what they call here the minimum point for the graph. It is also a turning point. Why is it a turning point? Because when it gets to this point, watch, it changes. Boop, it starts to go up now. Going up, it's not going down anymore. It gets to this point, all the time it was going down. And then when it reached to this point here, it just changes direction, it goes up. So that is a turning point. So turning points on a graph could be either maximum or minimum. Minimum point would be the lowest point on the graph. And a maximum point would be if the graph was going up this way. It reach a maximum value. And then it'll change direction and start to go down. And that happens when the value in front of the x is negative. So anytime you see a negative number in front of this x squared here, it means that the graph will be the opposite of a smiling face. What do you think it will be? Or what?
Frowning face.
Frowning face. Right? And it kind of, it lining up, right? Negative, frowning, positive, happy. Right? Be positive, be happy. When you're negative, you're kind of sad, you're frowning. Right? And when it's negative and it's a frowning face, it means that this here is going to be a maximum point. It's going to reach up to this maximum value and then change directions and come back down. Everybody understand now? No thumbs up if you understand now. Right, so rubbing off these 1,000,001 things I draw on the graph. Right. So I'm going back down to the question. Write down the coordinates at the minimum point in the form xy. We could do that now. We know what the minimum point is. We're going to get 3, -1. That's it. Right. Next one. Write x squared minus 6x plus 8 in the form a into x plus 8 squared plus k, where a, h, and k are constants. Right. So if anybody of you follow me on TikTok, I had a video showing you how to do this in some simple steps. We just run it through here again. Now, the equation, the coefficients is what is going to give us these values of a, b, and c, right? This is a, this is a b, this is a c. So I just now when I wrote the equation for the frowning face. So for this equation now we was given here, a is 1, b is -6, c is equal to 8. There's some formulas that I needed to learn. H is equal to b over 2a. Right, that's how it's find out what h is. K is equal to c minus a, open brackets, b over 2a squared. You had to learn these two formulas, right? So you could find what h is. H is equal to b is -6, right? So we have -6 over 2a. A is 1, 2 by 1. So h is -6 over 2. H is equal to -3. Right. K now, we say C minus A. So what's C? C is 8, A is 1. We just work out B over 2A, right? So I'm not gonna write that all of this back in here. I'm just gonna put the value of B over 2A and we could square that. So that's 8 minus 1 by 9. That's 8 minus 1 by 9, we get 1 minus 9. So K is equal to negative 1. So what we have here is values for H, we have values for K. We know that A is 1, right? If we go to our thing they want us to write here, A, H, and K. Everybody see now? And we know our values for A, H, and K. So we could write it now. We could say that x squared minus 6x plus 8 is equal to, what is the A? The A's are 1. This is always x. H is minus 3 squared, right? As you square there. And the K is minus 1. That's it for 3 marks. So we're not even out anymore, right? That's it. 3 marks. We're done there. On the same axis, draw the graph of the straight line x is equal to minus 2. G of x is equal to minus 2. So that's like saying y is equal to x minus 2. Now to draw a straight line, you already just need 2 points, right? So the 2 points you could do is you could always look for a y-intercept. Y-intercept is when x is equal to 0. So y will be equal to 0 minus 2. Y will be equal to minus 2. What I mean by that is basically is a point. When x is 0, y is negative 2. That's a coordinate. So 0 and negative 2 is a point on that line. And then we do the same thing now. We just find like a x-intercept. A x-intercept is just a fancy word for saying when y is equal to 0. So you take the same y is equal to x minus 2 up here. I replace the g of x with a y, right? If I didn't say that before. And I put 0 for the y. And I work out what x will be when y is 0. I just carry this 2 across here and I'll get positive 2. So x is 2. So the other coordinate is x is 2 and y is 0. Everybody understand what I do there? I essentially substituted x to be 0 to find out what y was, which was negative 2. And then I substituted y to be 0 to find out what x was. X was 2. Raise your hands if you understand that. Nobody understand that? Zakari? Salima? That's it? Yasmin, Yasmin say no. All right. So you want to draw a line, right? How is draw a line? To draw a line, you could go that long way they show in school to go and do a table of values and say, all right, x is 0, 1, 2, 3. And then they give you the equation y is equal to x minus 2. And then you'll go and substitute values now for the x. So if I put a 0 here, again, negative 2. If I put a 1 here, again, negative 1. If I put a 2 there, I'll get 0. If I put a 3 by the x there, then I'll get 3 take away 1 is 1. And all of these will be points that make up the line y is equal to x minus 2. Tell me if you agree with that. Thumbs up if you agree with that table of values. Yasmin say it. Brianna say it. Solana say it too. Brittany say it. Avalon, Tony, Jamari, Karel. Hey, the line here, they are told today, well. Everybody agree with that? Tony say yes too. Right. So all I doing is instead of going and find all of these values here, I just gonna find 2 values alone. Because to draw the point, I just need two points to connect, right? To draw the line, I just need 2 points to connect. So I gonna do y is equal to 0. So if x is equal to 0. So if this is the equation of the line, when x is equal to 0, then y will be negative 2. And then I'll say, all right, I'll take in the same equation of the line, and I'll put y to be 0 too. So then I'll be x minus 2 I want to find out what x is, so this becomes positive 2. So when x is 0, y is negative 2. And when y is 0, x is 2. Tell me if you agree with that now. That's me, give me a thumbs up, Brianna, right? Avalon, Rayan, Solana, Shaniqua, Tony, Brittany, Jamari, Karel. You all agree with that? Jamari, Idel? Idel, you good with that, right? Good. So I taken these 2 points, 0 and negative 2 and 2 and 0, and I'm going on the graph. Where the graph going? Right. What's the points I tell you? 0 and negative 2. So 0 and negative 2, the x is 0 and the y is negative 2. So here x is 0. I'll use a different color. So this is our point here. This is 0 and negative 2. X is 0 and y is negative 2. And then the other one was y is 0 and x is 2. That's this point here. So I could draw a line now connecting these 2 points. 5, 4. Right? Once it's starting at that 2, down here, and I go into the other one, I just extend it because it'll automatically line up with everything else. So to draw a line, basically that's what I say. I don't need to do a table with 4 and 5 points. I only need 2 points on the line and make sure that the line passing through them 2 points. And then boom, watch, I have a whole line there, right? This line actually telling me now, right? Like if I need to solve, and I'm sure that's what they're going to ask next. Hence solve the equation, you see? X squared minus 6x plus 8 is equal to x minus 2. To solve the equation, I'm just looking for the point of intersection of the 2 lines. You're looking at where that blue line that I just drew on the graph cut in the curve. That's the solution, that's the point of intersections. So where is it cutting the curve? It is cutting the curve at at this point here. It is cutting the curve at this point here, which is the point 2, 0. And it is cutting the curve at this point here, which is 5 and 3. Anybody see that? So the solution will be when x is equal to 2, y is equal to 0, and when x is equal to 5, y is equal to 3. Everybody understand now? Just 1 second. So, give me a thumbs up if you understand now.
Having problem sending the wire transfer to your account. I haven't set it up into my First Citizen bank as yet, but is it possible to give it in person?
All right, everybody understand how we draw the line and we found the intersection of the 2 points and how we solve that? Yeah. All right. So good. Yasmin is good. Brianna, you good there? Avalon, Idel, Tony, Brittany, Jamari, Karel. We good? All right, nice. So we have just completed our question set that out for relations. So we could take what do you want, like a 10 minutes? A 10-minute break. Right, so we're gonna look at our measurement, geometry, and trigonometry type questions now. Again, here we're starting from Jan 2016. We're doing some of the older papers. As we look back around, we'll do some of the more recent ones. All right, so we have the figure below, not drawn to scale, shows a circle with center O. The radius of the circle is 21 centimeters, and the angle HOK, which is this angle subtended at the middle here by O, that's 40 degrees, right? The radius is given as 21 centimeters, and it's to use pi to be 22/7. Determine the area of the minor sector HOK. So they want to know what is the area of this entire thing here. What's the area of that, right? A sector is like a slice of pizza from an entire pizza. That's basically what when we talk about the sector, that's what we're referring to. Now, there's an easy way for us to do this, right? The number of degrees in a circle is 360 degrees. The area of a circle is pi r squared. So, these two things referring to the same circle, agreed? Just give me a thumbs up if you agree that. A whole circle is 360 degrees. The whole area of the circle is pi r squared. So I could simply say that 360 degrees, which is the entire circle, is related to the entire area of the circle. If I find the area of a circle, I am finding the area of the whole 360 degrees of the circle. Now, with this relationship, I might be able to then work out what the area is for a piece of the circle. So if I say piece of the circle is 40 degrees, then I should be able to work out what the area of 40 degrees is. How? Well, there's this thing we do in primary school where we used to say 5 apples cost $20. One apple will cost how much? Anybody? How are we going to find the price of one apple? Anybody? Solana, you want to help me here?
$4.
$4, right? It'll be $4 for the cost of one apple. How we got that? Because we found for one, we divide the $20 by 5. So in the same way, if I want to find for 1 degree here, just like how I took the $20 and divide by 5 to find for one apple, 1 degree is going to be pi r squared divided by 360. And if I want to find for 40 apples now, won't I then take the 40 and multiply it by what we just worked out, 20 divided by 5, which is 4? Just give me a thumbs up if you agree with that. Yeah, we would. So 1 degree is pi r squared over 360. So if you want to find for 40 degrees, then we do pi r squared over 360 multiplied by 40 degrees. And that's how we'll find the area of that minor sector. Make sense? Yes? So let us work it out. Now, this is the concept here, right? Let us do a bit of working on the side here. We need the area of the circle. Pi r squared, right? You work it out so you can just put a figure there. They say use pi to be 22 over 7. R is 21 squared. So I do 21 by 21. We don't need to multiply it out, right? We gotta use a little bit of. So 1 here, 3 here. Agreed? Because 21 squared is 21 by 21. All right, let me just make life simple first. We'll go and multiply all of that out. So 7 into 21 is 3. So we end up with 22 by 3 by 21. Now we could go and multiply all of that out. That is what? 66 by 21. 1386. So we're going to get 1386 here over 360 multiplied by 40. Plug that into a calculator and drop an answer in the chat for me. Divide 1386 by 360 and then multiply by 40. $154, everybody get that? More thumbs up if you get 154. Yeah. Nice, good job. Just remember that area is in centimeters squared, right? So don't forget the units. 154 centimeters squared. And that's it. It works the same way for circumference too, right? All you will do is just change this pi r squared to the circumference instead. Right, next, we have to find the area of the triangle. Now, there's a formula for the area of a triangle. I'm gonna get on the space it in here too. Formula for area of triangle. I'll just write it because I'm not fine, you know. Half by B times C sine A. Right, so we have two sides, which will be our B and C, and our A is going to be at 40 degrees. So we have a half multiplied by 21, multiplied by 21, multiplied by the sine of 40. Right, we are on our calculators. 21 by 21 for 2 is 220.5. I sine of 40. 40 . That's going to be 141.73. centimeters squared. Everybody okay with that? Right, so this is when you do have like half base by height. You use this instead. Half by B by C sine A, right? So you should use the opposite side, so the 21, and then the angle in the middle. Cool? All right. So the area of the shaded segment now is going to be the area of the sector minus the area of the triangle. So area of the sector is 154 minus the area of the triangle, 141.73. And that is 154 minus 141.73. That's 12.27. Don't forget the centimeters squared, right? Centimeters squared. All right. Everybody all right with that?
Yes, sir.
Okay, nice. Good. So we're going on. So your favorite now, circle theorem. Now, it's have a way I want you to approach the circle theorem, right? There are a couple rules that you need to know, right? So, and certain things that we need to look for, right? We could look for our diameter or a line running through the center forming the base of a triangle, right? Which is really a triangle in a semicircle touching circumference. So before I actually get into the question, you're looking for these things. So I don't know if you guys could see it here, but there's a triangle where I just described here, right? There's a base running through the center, and this is a triangle inside of the semicircle here. Right? Let me semicircle on the side. Everybody see now? Give me a thumbs up if you see now. Everybody see now. Yeah? You all can see that? Tony, Carol, Jamari, Brittany. Yeah? Right. Right. So what that means, when that happens, the angle of the circumference is a 90-degree angle. So we know that this angle here, AD or CDA, is a 90-degree angle. Now, we may not need to find that, but we could use that in order to work out other angles in the triangle. The next thing we need to look for is any chords or arcs where we have multiple triangles resting. So there's a chord here. Look at this chord here. Bam. So it means that these two angles is going to be what? Equal, not so? Right? Those are going to be equal. Because that's the rule. Where you have two triangles subtended from the same chord or same arc touching the circumference, right, in the same segment, then they are equal. So those angles are equal. What other properties we have? Well, we have this smaller triangle here. Yeah, next color. This one here, where we have the radius being drawn from the ends of a chord. These radius here will be equal, forming an isosceles triangle, making these angles here equal. Right? So we can actually find those angles. So this angle here and this angle here is going to be 180 minus 72 divided by 2, right? Because they're both equal. What will that be? 180 minus 72. 1 second, guys. Sorry. Yeah, Mel. Yeah, in class.
Okay.
Right. 180 minus 72. 180 minus 72 will give us 108 divided by 2. That's 54. Right? So those angles there are going to write them in 54 a piece. Right here and right here, 54. Right? Now check that. This same triangle we were just talking about, this one. Bam, bam. Look, we have the two, but we don't have the two base angles. We have one. Right? So you still need to work out what this is. We have one here too. So we can't jump to any conclusions yet, but we have the base angles here. Let's see if we could, if they needed the answer anyway. ADC. ADC. No, we can't work out that yet. We're missing this little piece here. Right? Can we work that out? Yes, we can. Remember we talked about this triangle here being 90 degrees? You remember that? Had we seen that triangle? Raise your hand if you see the triangle. That's the first triangle we talk about. Green triangle. Base is passing through the diameter. It's a triangle in a. It's in a triangle in a Yes, sir. Hey, morning. What's going on? Hello. In the link in the I sent it in the maths group. I'm gonna send it back again. All right, so I'm gonna send it here. Right. So we saw this green triangle before. This green triangle is a triangle in the semicircle here, right? Where we have the base passing through the center and the angle is at the circumference. So this angle at the circumference, this entire angle here is 90 degrees. And we know piece of that angle is 54, right? So that is made up of angle ADC. Angle ADC is 90 degrees. See that? That's what we did before. Angle ACD now, ACD, right? So we know that this is 54. This entire thing here is 90. So if you want this angle on top of here, what will we do? 180 minus 54 plus 90. Everybody agree with that? Thumbs up if you agree with that. Anybody not seeing it? Just raise your hand. Solana. Right. So look at the green triangle, right? Remember, we work out the 54 using this smaller triangle here. This one. Right? Because this was a isosceles triangle. And to find that, we subtract the 72 from 180, and the bottom angles are equal. So we divide it by 2 to get 54. You agree with that? Give me a thumbs up if you agree with that. Right. After we did that now, if we look at that green triangle that I have now, that's now, I'm going to stick off these things here. The green triangle is a triangle in a semicircle. See the semicircle here? We have AO cutting the circle into two parts, even parts, making it a semicircle. See now? Give me a thumbs up if you see now. Right. And then we draw a triangle now with that AC being the base. So from here to here is the base, and the triangle coming up to here, touching the circumference. Give me a thumbs up if you see that. Right. So a triangle that is in a semicircle touching the circumference means that this angle at the circumference here is 90 degrees. Right? This angle at the circumference here, I'm going to just take off these blue lines. This angle to the circumference here, this here, is 90 degrees. Agreed? Thumbs up if you agree with that. Right. Now, if that angle is 90 degrees, and this one here is 54, so we have two angles in this green triangle. And we want to find this angle, then we will say 180 minus the other two angles in our triangle. Right? And I'm not talking about this. Let me just take off this right, so this is 90 degrees here. This here is the 54 degrees. We want to find out what this is. So we say 180 minus 54 plus 90. Give me a thumbs up if you understand that now. So we did this. This is the angle ADC. This is A here. DC 90. And now we could work out what this is. Right? Everybody okay with this angle? ACD. AC, this is the one we want to find, D. So it'd be 180 minus the 54 plus 90. And that works out to be 180 minus 144, 36. So this angle is 36 degrees. Right? So I'm taking off some of these things now, right? So we could write in what we have. This angle here is 36 degrees. Angle CAD now. CAD. We worked out that already. That's this angle here, not so? How much degrees is that? Put it in the chat for me. That was this one we worked out here. Agreed? Anybody remember how we got an angle? Using the isosceles triangle here. Yes or no? Thumbs up if you remember how we get the 54 degrees. Solana, you alright with that? Zubri, Joshua, Lakari, Tony, Jamari, Brittany, Brianna, you alright? Yeah, good, Brianna, good, good. Right, so everybody remember how we get up. Then we have the angle O. This is O. E. This one out here. A. So they want this angle on the outside here. Right? OEA. Okay, good. Shouldn't go back in. Nice. Yeah, go ahead.
Wasn't A be like the whole piece? Would that include the whole piece?
A be the whole piece. Well, is a point. So it depends on the other two letters that involve. So the three letters always form the angle. So if I say ADC, we're talking about from the point A to D to C. So we're talking about this whole thing. If we say ACD, we're talking about from A to C to D. And then when we see C, A, and then to D, we're talking about this line here. Here, here. So we're talking about just this little piece, not the whole thing. Understand?
That's the
Yeah? All right. All right, so I'm going to take off that. Right, so we want to do OEA. This one, we had to look at the rule for an angle on the outside of a circle. I'll tell you what our rule is now. Yeah,
What was for example A for the first one? Again, for ABC, what was the example?
that's the 90-degree angle.
Yeah.
Right, the 90-degree angle is we have this one, triangle in a semicircle touching the circumference.
Okay.
Right, the 36, well, some of the angles in a triangle is 180. And then for this one, 54 degrees, the ends of a chord extended to the center forms isosceles triangle. Oops. Where base angles are equal. So we use 180 minus 72 is, how much you got there? 8. And then I 17 take away 7, 108. And then we divide that by 2 to get 54. That's how we got this one. And then lastly, we're going to do this one now. This one, I'll tell you for that one now. It's the angle on the outside of the circle. Right, angle made by a tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment. Right? Or we could look at OAE being 90 degrees. Right? Because we have a radius and a tangent at OAE. Right? And if that's 90 degrees angle OAE, we could look at the triangle, which I think is the easier way to do it. I need to rub off some of these things here, right? I like to work with the triangles where I could just sum up the angles in between. Look at this triangle here. Oh gosh. I'll draw that crop the foot. That's one line in the triangle, right? One side. Look another side here. And look another side here. Everybody see that triangle? Now, when we have a tangent as a tangent. A tangent is a line touching the circle at one point, and we have a radius meeting the tangent here. It meets the tangent at a 90-degree angle, right? Because, well, obviously this is a 180 degrees on this line here. This radius is perpendicular. So what that means is that the inside angle here of this green triangle that we draw is 90 degrees. This is 72. So if you want to find for this other angle on the outside here, what are we going to do? 180 minus 72 plus 90. Everybody see now? Give me a thumbs up if you see that triangle. And the rule here is tangent is perpendicular to the radius of a circle. Right, so OAE is equal to 90 degrees. And then we do sum of our angles in a triangle. It's 180 degrees. So 180 minus 72 plus 90. Anybody not seen it? 162, 18. Raise your hand if you just want me to recap that. Everybody good with that, right? Yeah? All right, so I'm moving on. All right, so another nice. Cool. So this one wasn't too bad. Everybody all right with that? All right, so we're gonna look at the other one now. Just June 2016. And again, remember what I tell you these, right? You want to try and you don't want to leave out any of these questions. You want to try and attempt them. Because every little mark that you make going to count. You all want to try? All right, somebody will say you want to try this one on their own. You want to try it on your own? Try it and then I'll do the solutions. Everybody can see it? I'm going to just make it all bigger. Everybody seen it, right? Give me a thumbs up if you could see the entire question. Now remember the rules that I told you, right? Look for chords. Look for isosceles triangles. Isosceles triangles will always have the two radii joined by a chord. Look for tangents and a radius. Tangents and radius will always meet at right angles. Here you have tangents and radius meeting at right angles, right? Look for things like quadrilaterals. Some are quadrilaterals. You have a quadrilateral here. That's a four-sided figure, like a kite. The sum of the angles, they're going to always add up to 360 degrees, right? You have cyclic quadrilaterals inside of this circle too. You have this, right? These triangles here are isosceles triangles because the two sides would be equal, right? They're both radii. These triangles here will also be, this triangle here will also be isosceles, right? Look, you have a triangle in a semicircle here, right? You also have another one on this side here too. Right? What else we have? Look for chords. Look, you have a chord here. Look for if you've seen any triangles resting on a chord. Look at a triangle resting on a chord here, and another one resting on a chord this way. So it means that this angle and this angle is the same. And the same thing will happen on the opposite side. Watch. Triangle here, and look the other triangle here. Oh gosh, I draw that kind of crap. This line here and this line here. So it means this angle and this angle, the small one, will be the same. You all seen all those things? So you have to look for those, you have to look for those patterns for these questions in order to be able to answer it. It's all about a looking game. Right? You have to look for the relationship. So I'm going to give you a chance to work it out, and then I would do the solutions. So 2 marks per question. I've given you all 8 minutes. So this first one we needed to find EHF, right? EHF. We're using this rule here. From a point outside of a circle, if 2 tangents are drawn to touch the circle, the length of those tangents are equal. It also follows that if a chord is drawn between the points of tangency, so this is where the tangents are meeting the circle, right? At H and F. If we draw a chord between there, what we will form is a isosceles triangle, right? Because these 2 lines here are going to be equal, and it means that we could find the base angles by taking 44 away from 180. That would give us what? 180 minus 44, 136. Yeah, very good. And the base angles will be equal, so we divide 136 by 2. That will give us 68. So each of these angles here is 68 degrees. Everybody got that? Yeah? Good. The next one, part 2. FGH now. So we're looking at, I need to rub off some of these blue lines from here, right? We're looking at sorry, my bad. We're looking at F to G to H, right? Now, if we look at FGH, remember I tell you, you must always look for, I'm taking off some of these things here. You must always look for triangles that are resting on a arc or a chord, right? There's a rule that says the angle, if 2 triangles are resting on the same chord or on the same arc, the angle at the circumference, right? This angle here at the circumference is going to be half the size of the angle at the center, right? Usually that would look, it's easier for you to see it when it's drawn, right? Let's just say this is the center here. And let's say I draw, this is the rule. It's just that sometimes the way it's drawn, you all don't always see it. You remember this rule? So if I say here is 120, then this angle here is 60. Just give me a thumbs up if you remember that rule. Both angles sitting on the same arc. This is the arc AB here. One is at the center, one is at the circumference. The angle at the center is twice the one at the circumference. So if this is 60, this is 120. Or said another way, the angle at the circumference is half the one at the center. Now, how can I find this angle at the center here? Anybody have any idea how I could find out? Remember, I tell you to have a cyclic quadrilateral. Well, not cyclic quadrilateral. We have a quadrilateral. There's a kite here. Now check the easy thing about this kite, right? This point here, there's a tangent and there's a radius. So guess what's the size of this angle here? Anybody?
90 degrees.
Yep. And then check what's going on here again. You have a radius here. See the radius? And you have a tangent here. So guess what's the size of this angle of the kite to? 90 degrees. So the sum of angles in a quadrilateral is 360. We have a kite where here is 90 here is 90, underneath here is 44. If I want to find this angle here, then I could take 360 minus 90 plus 90 plus 44. More thumbs up if you agree with that. And just scroll along so you see the triangle better. Everybody see now?
So what's that over, please?
Draw it over.
Yes, sir.
All right. So watch my triangle. Watch more kite here, right? See now? These are coming from the center. So these are radius, right? This is our tangent here, agreed? So this is a 90-degree angle. Agreed? Just give me a thumbs up, everybody, if it is your seeing these things. Right? This is a 90-degree angle too. Everybody see now? Kirel, Jamari, Tony, Joshua, Idel, Brianna, Avalon. Everybody see now, right? Christian, nice. Right. So it means that in this kite, I have three known angles. There's this 90-degree angle here. There's this other 90-degree angle here. And there's this 44-degree angle here. So the one missing angle here that I don't know, I could just add these three up and subtract from 360 in order to find it. 180 plus 44 is going to give me 224. And 360 minus 224 is going to give me 136. So this angle in the center here is 136. Everybody agree with that? Give me a thumbs up if you agree with that. Nice. Good. Now using this rule here, where I need to rub off these red lines, right? You know the 136 there. Where we have this arc, and I have this point at the center here on this same arc, and then I also have this one out here on the same arc. See that? It is the same thing like this. Even if I take a line and I draw it this way instead, which is essentially what we have there. Isn't this the same thing as this? Isn't this going to be the same thing as that? Yes or no? Give me a thumbs up if you agree. It would, because they're both on the same arc. One is at the center, one is at the circumference. So it means that this angle here that is at the circumference, this angle G, is half of this angle here. What's half of 136? That, you know what, 68 as well? Yeah? 136 divided by 2. Yeah? Also 68. Everybody see that? You understand how we get that? Just raise your hand if you understand how we got it. Yeah? Avalon, Rian, Zubri, Idel, Selima, Tony, Kirel. Right. Anybody do understand how we got it? Raise your hand. Do understand? No, we good? So we're going on to the other one. Right? Right. So I'm going on to the other one. The other one, real easy. Why it's real easy? Because we have the tangent here and we already talked about that. And we have our whole diameter here. And they want us to tell us what the angle J HE is. Anybody can tell me what the angle is? Use the mic if you want. Salima, what do you think that angle is? You have a radius meeting a tangent.
90.
90 degrees. Very good, Dakar. Right? And then last we have, check this one too. Easy again. J, G, H. This is J, this is G, this is H. We see this triangle here. This triangle is a triangle, you know. Now what? Look at this, look at the base of this triangle. We're passing through the center. Right. So what is the angle here going to be? 90 degrees. See that? So here's 90 degrees. You good with that? Everybody all right with that? Don't worry, you're almost done with this. You're almost done. All right, I'm going to cut another question here. We're looking at trigonometry now. I know you don't like that sickle term at all. Yeah, that fight up with it. Don't leave any marks on the table. The diagram below, not drawn to scale, shows two ships, R and S, at anchor on a lake of calm water. FT is a vertical tower. FSR is a straight line. And RS is 150 meters. Right? So between R and S is 150 meters. The angular elevation of T. So the angular elevation is the angle that you make when you look up towards the top of the tower, right? Is 22 degrees and 40 degrees respectively. So this is 22 degrees, this is 40 when you look up to the tower from these respective points. Calculate, given your answer to one decimal place where appropriate, the measure of the angle RTS. So they want this angle instead, RTS, right? Sorry, RTS, RTS. They want this angle in the middle here. How are we going to find that angle? Anybody? Anybody have any ideas? Well, you have to.
Sine.
No. I'll tell you why though. We use sine and cosine rules for non-right angle triangles. Right? Because this is a right angle triangle, right? We would use our normal sine, cosine, and tan, right? Now, this triangle here is actually a non-right angle triangle, but you don't have enough information here in order to use a sine or cosine rule, right? So what you'll actually do though, is you could work out the size of the angles in two triangles. There are two triangles here. I'm gonna draw them first so you see better. Everybody see any two triangles? We have F, S, and T. And then we have the same F, we have the same T, but then we're going out to R. Now, when I separate it like that, check what happens. You have a 90-degree angle here, you have a 40-degree angle here. Agreed? Then you have the same 90-degree angle here, and you have a 22-degree angle here. How I could find this missing angle? The easiest way to find our missing angle is what? Think I need to use sine, cosine, or tan? Angles in correct. Angles in a triangle is the sum of it is 180 degrees. Now, if I do that and I get the size of this angle, when I do the bigger triangle, which is the green triangle, I will get the size of all of this because the bigger triangle is from here to out here. Everybody see now? You want thumbs up if you see now. Everybody see now? The bigger triangle is going to start from here to go to this line here because it will now be TF and TR. Look at where TF is. This is TF. And then quite out here is TR. So if I subtract those two angles, right? If I do it like this whole thing here, and if I subtract this piece from here, then I will remain with what they're asking for, the angle RTS. Everybody agree with that? More thumbs up if you agree with that. Yeah, the difference between the larger angle and the smaller angle will give you this little piece in the middle here. Right, so work out that for me. You all try it, and then I will do it here. So I will write angle RTS is equal to angle FTR minus angle FTS. So you all are finding these two angles to me. This angle here is FTR and this angle here is FTS. Everybody understand? Right, so for FTS you're doing 180 minus 90 plus 40. And here we're doing 180 minus 90 plus 22. Cool? We'll go that one. Yeah?
I don't understand how FTR is a right angle triangle.
FTR. This is the same tower. This tower not moving. It just at different points looking at the tower. So in one triangle, you're here at S.
So not FTR, I mean STR. And so you have to separate it like separate FTR and STR.
STR. STR is not a right angle triangle. STR is a non-right angle triangle. STR is this triangle in between two of them here. That's not I get a rub off these things. As you're asking, right? STR? STR is this triangle here. That's a non-right angle triangle. That's what you're asking, right? Yeah?
Yes, I was confused how you have to find FTR, FTS, and then FTR, but understand.
Okay, all right, you seen it. Good. Yeah. Because I use the same tower. This line is the same for both of them. See? It's just that one triangle is smaller, so you have a smaller angle here. And then the other triangle now, we pretend like this line do exist. And we just find a big triangle now. So we find the size of this big angle here. And then when we take a really smaller angle from the big angle here, B minus X, we will find this little piece. Make sense? So let's see what I get. So this should be 180 minus 130. So that's 50 degrees. And then this is what? 180 minus 9 and 2 is 11. 8 more to make 20. 68 degrees. Yeah? Everybody got that? 18 degrees. The more thumbs up if you got that. Still working, I rush over there. Oh, sorry. ST, how are you gonna find ST as we already here? ST, we could use our ratios, right? So my teacher always used to make us draw over these triangles. You hear me better now? No? Let's see. Why is that? Why is that? Testing, testing. Hear me any better now? Anybody else? Jasmine, hear me properly. Okay. Everybody, just give me a thumbs up if you hear me properly. Brianna is all right. Okay. Good. All right. So I'm going back. Christiana is good too. Okay, good. All right. So I'm going back to the question. Now, my teacher always used to make us draw over these triangles, right? Instead of using the one triangle over and over and over. And it would help because then you'd be able to identify what you need to do. So we okay in terms of how we got 18 degrees for part one, right? Just give me a quick thumbs up if you're okay with that. So part two now, we want to find the length of ST. Now ST is on this triangle here, the triangle that has FT as my tower. This is 90 degrees here, and this is 40 degrees here where S is, right? And we could use our sine, cosine, and tan here. What do we have? This is our hypotenuse. This is my adjacent at the bottom here. This is my opposite. ST is the hypotenuse, right? Do we know the height of the tower? Vertical tower, no. They said that FSR is a straight line. Okay, nope. This is the car. This is where we're going to use our cosine rule now. So wrong triangle. We can now take this triangle here because guess what? We have 22 degrees here. We have 150 meters here. And we just work out this to be 18 degrees here. Agreed? This is S. This is T. This is R. Jasmine agrees. Everybody else agree with that? So what we have? We have two angles and a side. Two angles and a side is the indication that we could use our sine rule. Right? A cosine rule we could use when we have three sides or two sides and the angle in between. Right? So this is the easiest way to learn it. Cosine rule, you use when you have three sides or two sides and an angle in between. If you're not meeting any of those criteria, then you're going to use the sine rule. So let's look at it. We have S, this will be little s, this will be little r, and here will be little t. Now let us look at the values that we have. I think we need a little more space. Try to do this one lower down. Let us look at the values that we have. So we always start with what is given. So we say we want to use sine rule. So given, we know that little t is equal to 150 degrees. We know that capital T, which is the angle, is 18 degrees, right? We also know that R, big R, is 22 degrees. And guess what we want to find? The side ST, which happens to be what? Little r. See now? So what we take away from what we did so far for this question, it's always important to redraw the part of the triangle that you're going to work with. Secondly, it's important for us to label the triangle, include all of the information that we have. Length of sides, angles, label the triangle. Then write what you was given, write what you're required to find, and that's going to help you to determine how you're going to go about your solution. So my solution, as we said, is to use the sine rule. But guess the values you're going to have to use here. It's going to be t over sine t is equal to r, little r over sine r. Everybody okay with that? Hands up if you're okay with that, up to this point. You follow where I took the things that was given, what we required to find, how we're going to pursue a solution using sine rule. We're using sine rule because it does not fit the criteria for cosine rule. The criteria for cosine rule is that we must know either 3 sides or 2 sides and the angle between the 2 sides. We're not meeting any of those criteria, so it means that we have to use sine rule. The formula for sine rule is a over sine A is equal to b over sine B, right? Or if it is you're not using one of these, it could be like a over sine A is equal to c over sine C, right? The point is that you'll always have the length of a side over the angle, right? T is the length of a side, T is a capital T is the angle. R is the length of a side, capital R is the size of an angle. And we have values, you need to have values for 3 out of the 4 unknown things in a formula. In every formula, there are 4 unknown things when we do the sine rule. There's 1, 2, 3, 4. In order for this to work, you have to have 3 values that you could enter. We could enter 150 meters for T. We just work out that the size of this angle here is 18, so we could put that as 18 degrees. The R is the ST that we're trying to find, so let us write ST there. And then the capital R, the angle R is 22, sine 22. Get my hands up if you're with me up until this point. Everybody, let me know. Anybody not with me up until this point, drop a N in the chat. A N in the chat if you're not with me up until this point and you want me to recap. Right. So I'm recapping, right? First thing I'm doing is I'm pulling out the triangle. I'm going to draw the triangle over here. So we have so this was my, this is the triangle here, right? This is T. We just work out this angle here to be 18. This is S, right? This S here, R. Length of SR is 150 meters. The size of this angle is 22 degrees. We must label a triangle. So in labeling a triangle, the side opposite S is going to be little s. The side opposite R is going to be little r. The side opposite T is going to be little t. I'm then going to write the values that I have given, right? So given, I have T, which is 150 meters. I have R, which is 22 degrees. I have T, which is 18 degrees. So those are the 3 things that I have. You okay with me up today? Give me a thumbs up if you're okay up today. Right, so we need 3 out of the 4 things in the sine rule formula in order to make it work. The sine rule formula, if I just write it on the side here, the generic formula is A over sine A is equal to B over sine B, right? Doesn't matter if they change up the letters. How much things we counting here? We counting 1, 2, 3, 4 things to make up that formula. In order for this to work, we need to know 3 things out of the formula. We have 1, 2, 3. The thing that we have to find is this side here, ST. ST is this little r. So I am required to find, RTF means required to find, ST, which is little r. Give me a thumbs up if you're with me up until there. Good. Now using the same general format for the formula, right? Sine rule formula, you'll have matching letters, right? So common A, capital A, common B, capital B. Let's go and see what we have here. We have a common T and a capital T. So that forming this part of my sine rule. And then I have a capital R and I have to find the common R. So that forming this part of my cosine rule. So give me a thumbs up if you're with me up until that point. Everybody with me up until that point, right? Whitney, Idel, Zuberi, Christian, Rian, Avalon, nice. Brianna, nice. Right, good. Now I'm going to substitute the values that I have. So I'm going to take off all of these green circles, right? Too much green, too much. Right. So what are substituting? I'm substituting this little t is 150. This is meters here, right? 150 meters. The capital T is 18 degrees. The capital R is 22 degrees. This R is the length of the side ST. That's what we're trying to find. They say find the length of the side ST, right? So we substitute those. So we're going to find ST. Now to find ST, anytime you're given a question, algebra question where you have two fractions that is equal to each other, right? Meaning like you have A, B is equal to X, Y. Anytime it is in this format, you can always cross multiply in order to work it out, to solve it, right? So it's in that particular format. So we are going to cross multiply. Why am I cross multiplying? Because it's going to change it from being fractions into a nice linear equation where I could work out, well, ST is equal to everything else, right? So check me now, right? Top by bottom, bottom by top. So I will get sine 18 multiplied by ST, right? This here multiplied by this is equal to 150 by sine 22. Now remember, I want ST. So just like changing the subject of formula when we was doing the functions a little while ago, we have to move this sine 18 across here. This sine 18 is multiplying by ST. So when I take it across, we're going to actually divide this entire thing here by sine 18. Right? So we go to our calculator. We do, I will prefer to put sine by 22 or sine 22. Then I multiply by 150. Right? And then I will divide by, I don't open my brackets, sine 18. And I get in 588.44 meters. Everybody okay with that? You need me to show you on the calculator? Just raise your hand if you need me to show you on the calculator. How to enter it. Jasmine? Okay, no problem. 1 second. Supposed to have a on-screen sharp calculator here. I'm gonna open it fast here. And downloads. So much things are wrong with it. All right, I'll find it. All right, so we're going to the calculator now. All right, I need to change my screen share. Screen share, present something else. Right, there we go. Right, so this is how we're going to work this out, right? So you're doing it up first. You're doing, everybody can see calculator, 150 by sine 22, close brackets, divided by open bracket, sine 18, close bracket. Right? 181. So you see, yeah, the one I did before was on the calculator on the computer. So you want to make sure and enter this properly, right? You could do sine 22 as well, multiply by 150, and then divide by sine 18. 180, 1.8, well, 84. Everybody right with that? Just raise your hands if you understand how we do now. 181.84. The thing we check it there. Right, and don't forget your meters. Right, always remember to put back your meters. Right, so let's switch back to our our whiteboard. Right, so that's the length of ST, 181.84, and we could just write it to 2 decimal places. Right, and we're good to go there. Everybody right with our question? Give me a thumbs up if you're okay with this question. Yeah? All right. So now, again, this is just going to the last part of the question, the height of tower FT, right? So now that we know that ST is 181.84, again, this is why my old maths teacher was used to make us draw these triangles over. We want to they want the tower FT now, right? So look at it. They want this tower here. So we just work out what ST was. We know the length of that side. We know that this is a right angle triangle. We know that this is a acute angle there, 40 degrees. So we could use our sine, cosine, tan, one of them in order to find out the length of FT. So let's draw that triangle. 40 degrees here. the length of this side, which you just work out, which was, this is ST, and this is F underneath here. ST was 181.84 meters. We want to find X here, FT, right? This is 40 degrees. So let's label our triangle. This is my hypotenuse. This is my opposite. What I'm trying to find, this is my hypotenuse, and I have more theta here. So looking at sine, so, ka, twa. We need a formula that has both opposite and hypotenuse in it. This has opposite and hypotenuse, so that's a good option. This has hypotenuse but no opposite. This has opposite but no hypotenuse. So it means that we need to use sine. Use sine ratio. We write the formula. Sine theta is equal to opposite over hypotenuse. We write what we have. Theta is equal to 40 degrees. The hypotenuse is equal to 181.84. We want to find the opposite, which is x. So we substitute our value. Sine 40 degrees is equal to x, which is that ft that we're trying to find. And this is 181.84. We cross multiply. So sine 40 multiplied by 181.84 is going to tell us what x is. So I do sine 40 and then the scientific calculator. Right, so sine 40 multiplied by 181.84. Again, 116.88. So 116. So FT is 116.88 meters to 2 decimal places. Everybody all right with that? Give me a hands up if you're okay with that. Thumbs up, hands up. Yeah? Everybody right? Nice. Right, so that was the tricks question. We have one more here to finish up. What we do, 11, 15, 12, 15 hour. We almost at 2 hours. You wanna jump into the other one time, or you wanna take a break? Yeah?
Are you doing bearings?
Yeah, we have a bearings question right here.
Yes, sir.
Yeah. Do I want to do this one time? If we finish up this one, then we will finish the measurement and tricks questions. So when we come back, we could go into the vectors and matrices. We'll push through a half hour again, and then we could take a little break for lunch, and then you could we resume and finish the vectors and matrices. All who want to push through, raise your hands. Nobody. I give me a thumbs up if you want a break now. If you want to go take a break, get some lunch, and then start back. Thumbs up if you want lunch now. All right. That's all I want lunch. The carry you lunch now. Hey, what about you? Brittany, Brianna, Joshua. Brittany, you here for lunch? Hey, you here for lunch? All right, no problem. Then those last couple of questions was intense. All right. So here what is 12:50 um, we could break for, I don't know, I think like if you do one half hour, that should take us to what, 20 past 1, right? That should be enough, half hour. You're okay with half hour? I think that should be enough. Right, a half hour. Yeah, Brianna say yeah. Half hour and then resume. You don't want to break too long because then you'd lose your momentum and yeah. Right, so half hour and then we resume. If you want to come off the call, that's all right. I will just message your group when we're about to restart, all right? Right, so with this question, we have
So 20.
20, right? This question, the angle HKL is going to be 20. And why is that? We have, say to state a reason, angles at the circumference that are standing on the same chord, right? Or even what to call it, the arc HL, right? So that's how we're gonna get 20 degrees for HKL. The other one is angle, I'm just gonna rub these off now. Good job, Solano. The other one is angle. Yes, that's correct as well too. Angles resting on the same arc in the same segment are equal. That's perfect. Very good. Right, we have this now. We want to find out what. Why do not I want to arrow? Right, they want us to find JOK now. JOK. So we're talking about this angle in the center here. What we have happening here? Do we have a chord? Can everybody see a chord between J and K? Thumbs up. Tell me if you see the chord. J and K. There's a chord there. And then from the ends of the chord, we have our two lines going to the center, which will be two radii, forming an isosceles triangle, making this other angle here being equal 50 degrees. So that means angle JOK is equal to 180 degrees minus 50 plus 50. 180 minus 100. It's going to give us 80 degrees. So when we have a line drawn from the ends of a chord to the center of the circle, this forms an isosceles triangle where base angles are equal. We also have the sum of angles in a triangle is equal to 180 degrees. So those are the two rules that we're using to find that. All right, everybody okay with that one? Just give me a thumbs up if you're all right with that. Yeah? Good. Everybody right? Nice. So we're going on to the other one now. Now this other one, I want to just drop the rule here. I have a diagram that I want to share with you guys. This rule is the alternate segment theorem, right? So basically, what it says is that the angle that lies between a tangent and a chord, right? So this is the tangent here, and this is the chord, is equal to the angle subtended by the same chord in the alternate segment. So in the alternate segment, this is the angle subtended by the same chord, right? Those angles are equal. So what we have happening here is that our radius is meeting this chord here at a 90-degree angle, right? Everybody seeing a 90-degree angle. We have 50 degrees here, so this other angle here is going to be 40 degrees. This is the same, or this is going to be size of this angle on this side. Here is also going to be 40 degrees. And that's based on our alternate segment theorem. See it? Exactly the same. This angle here is equal to the angle in the opposite side. Same segment, opposite side. Everybody seen it? Just give me a thumbs up if you seen that. Yeah? Right. So angle JHK is equal to 40 degrees. We also use the angle between a tangent and radius is 90 degrees. Right, so those are the two that we use. Cool? Nice. So we're going on to this one now. A ship travels from A on a bearing of 30 degrees. So when we talk about bearings, bearings looks at the degrees from north that we move, right? So you have, if we have 2 points, let's say we have the point A, better. I use this example at a class I did a couple of weeks ago, right? Now we say we're in a room, right? Brianna, you gotta bear with me, right? Because I using areas in Trinidad. So Arima is in more the eastern part of Trinidad, right? So this is north going this way. And then if that's north, then this is south. This is west. This is east. Right? Brianna is from Antigua. So to the north of Arima, we might have Blanchy shares. I think that's how you spell it. Right? And then I could say maybe I don't know, we could have Matura on this side. This is going up more Toko side. Then we have Miyaru somewhere down on this side. Right? Then we could have maybe Princess down here. Then San Juan would be due west of Arima. And maybe Santa Cruz might be somewhere here if you want to put St. Joseph here. Right? This makes sense to everybody, right? In terms of where I have the locations. I don't know how well you all know your country. But generally, well, you must know Sawan and Arima because both of them running on the bus route, right? So when we talk about the bearing that a place or a town might be from another, we're talking about it in terms of the direction in reference to your due north. Now, the cardinal points is broken up into east, west, north, and south, right? And it forms a complete circle. We can also describe, different parts of our cardinal points in terms of degrees. North is 0 degrees. East obviously is going to be 90 degrees. South is going to be 180 degrees. West is going to be 270 degrees. Right? If we look at in the middle of north and east, we're going to have northeast, which is 45 degrees. here is going to be southeast, which is another 45 on that. So that's 135 degrees. Everybody hearing? I hear some people saying they're not hearing. The Carrie hear me? Shiniqua, Joshua. Can you guys hear me clearly? Just give me a thumbs up if you're hearing clearly. Is everybody hearing? I've seen it moving here, so. Ah, you giving trouble?
I can hear you, but it sounded like it's raining in the back.
All right. So let's see. Why would that happen? All right, excellent. Good. So we're good to go. Right. So I was saying, let me recap. So recapping. When we talk about bearings, we're talking about reference to our cardinal points, which is north, east, west, sorry, and south. North is at 0 degrees because this we're making an entire circle going around, right? If anybody ever look at the compass on a phone, you'd realize that it tells you in number of degrees where your location would be. It could be how much ever degrees north, east, south, east, southwest, right? So on and so forth. So the main cardinal points are at 90-degree angles from north, east, south, and west, right? So it comes all the way back around to 360 or 0 degrees, right? Full circle. So we also have the midway point. So between north and east is northeast, and that'll be at 45 degrees. And then between south and east, you're gonna have southeast, and that'll be at 135 degrees. And then between south and west, you're going to have southwest, and that's gonna be 225 degrees. And then here between north and west, you're going to have northwest, and that's gonna be 315 degrees, right? So when we talk about the bearing of a place or a point from another, right, we're basically looking at from your north arrow. If we draw, we check the number of degrees that is going to line up between these 2 points. What is it going to be? So let's take, for example, Arima and Matura. So let's just say we draw a line from Arima to Matura. The bearing of Matura from Arima, from is always our starting point. Could be estimated to be, right, based on my drawing here. If this is 0 degrees and this is 90 degrees here, it's not looking like half. It could be a little more than half. So let me say, I don't know, closer to the 90. So let me call it a bearing of 65 degrees then, right? We just estimating. So the bearing of Matura from Arima is 65 degrees. How am I calculating that? I am drawing a north arrow on Arima because that's my starting point. I am then connecting Arima and Matura by a straight line between both of them. And I am looking at the number of degrees from north it takes for me to get to that line that connects Arima and Matura. And that tells me the bearing that Matura is in reference to Arima from Arima. it is at a 65-degree bearing. Everybody follow that? If I talk about the bearing of Meyaru now, Meyaru is underneath here, right? Meyaru will be on our bearing. If we check from the north coming all the way around, remember this is 90 degrees here. Underneath here will be 180. So we could say that, you know, this looking kind of like the midway point between the 90 and 180. So let us assume that that is 90 plus 45, which is the midway point. That'll be 135 degrees. So Meyaru is on a bearing of 135 degrees from Arima. Everybody understand that concept of bearings now? Just put a thumbs up if you understand how we actually view bearings. Thumbs up in the, right. Everybody, right? Anybody do understand? Raise your hand. Don't do the thumbs up. Do a raise hand and I will know. Right. So everybody understand. Good. So when we have these questions to do, this is why they took the liberty of drawing north arrows and these points for us. Because we are going to use these north arrows now to draw in or to write in these bearings that they're talking about. Now, the thing with north arrows, just as I was showing you just now, you know for a fact that with north arrows, it is broken up into 90-degree angles. So you could use this property sometimes in order to work out missing angles, right? So let's talk about it. So the ship travels from Akron or Akron on a bearing of 30 degrees. So that just like the Arima example I give you, right? From is always a starting point. On a bearing of 30 degrees to Belleville. So that was just like the Arima and Matura, right? And I say it was 60 degrees. So this is Arima. I pretend this is Arima, right? This is the north arrow. So we always, my teacher always used to make us draw the little north arrow and the cardinal points on it there, right? So we know that this is a T pretty much. So that 30 degrees that they're talking about to Belleville from Arima is from this north arrow to here. That's where this 30 degrees that they're talking about is being formed. Everybody agree with that? Give me a thumbs up if you agree with that. Good. Now, what other angle properties can we determine from this? We could also determine other angle properties here because we know that this here is meeting at a T and that this whole thing here is supposed to be 90. So if that whole thing is supposed to be 90 and we have 30 here, it means that this angle inside of here will be how much? 60. Tell me if you agree with that now. Give me a thumbs up if you agree with that. So you see how you're using your angle properties and the cardinal points now to work out other angles that wasn't originally given in the question, right? Good. I didn't really read what they want us to do as yet, right? I'm just showing you how we can pick up on certain angle properties. The other angle properties I want you to learn and to remember, right, is that the north arrows are parallel to each other. So they are forming what we call supplementary angles, meaning that the angles in between the two north arrows here, the sum of these angles will always be equal to 180 degrees. So if here is 30 degrees, let's make sure I'm telling you the correct thing. It has supplementary and it has complementary angles. Right. Good. I know that. I had that mind, so I'm mixing it up. Supplementary angles is the angles on a straight line. Complementary angles is what is the word I have to use. No, neither. Complementary angles is 90 degrees. Oh, I know it is. Co-interior angles. I'm going through, I'm going through. I'm totally going through. Right, co-interior angles. Oh, that's come with age. Well, they can excuse me for that. Or they can excuse themselves for that. So the sum of co-interior angles co-interior angles is 180 degrees, right? So what that means is that if here is 30, then this angle here will be what? But tell you the sum of them, co-interior angles add up. This angle here will be how much? 150. Agreed? More thumbs up if you agree with that. All right. So you see how we're making progress and we're finding all these different angles, right? Good. Let's see what else they talk about here. Right. So we put in the 30-degree angles. They say A, which is on our bearing at 30 degrees to Belleville, is 90 kilometers away. So the length of this line here is 90 kilometers. Everybody agree with that? Right? A to B is 90 kilometers. It then travels to Compton, C, which is 310 kilometers due east of Akron. So due east, if this is more north, south, west, east here, C is 310 kilometers due east of A. It is in line with A going due east. So that's where the 310 degrees kilometers is. The carry, remember when we talk about cosine rule, I mentioned that the times when you could use cosine rule is if you have three sides or two sides and an angle between. You see any two sides and angle between here? Everybody give me a thumbs up if you see any two sides and the angle in between here. I just write over this. What's the two sides of this here? 90 kilometers, 310 kilometers, and 60 degrees in between. Right? So automatically, I ain't read the question fully yet, right? But I am already framing my mind as to what it is I could use or what it could possibly be coming with. Right? So we're writing all of these things on our diagram, and I want you to practice doing that too. You're putting in the information so that as I ask the question now, you're on the ball. Right? Indicate on the diagram the bearing of 30 degrees, right? You all did that. The distances of 90 kilometers and 310 kilometers for 2 marks. See how I tell all the marks is just be on the table for you to take. That is 2 marks there just for drawing them things on the diagram. You didn't even work out anything as yet. You probably don't even know what the cosine rule is, but you get 2 marks for entering it on the diagram, right? Don't leave nothing on the table. Part 2, calculate to the nearest kilometer the distance between B and C. So this is where we're going to use the cosine rule. Let us label this triangle, right? I'm going to label the triangle. Now, when you're labeling a triangle for cosine rule, you look at the letters. If this is capital A, you look on the opposite side of capital A. If you're not sure, just draw an arrow on the first line I touch, that is opposite. This is going to be little b. Sorry, little a. Why I say little b? This is going to be little a. On the opposite side of B, draw a line if you're not sure. This is going to be little b, and well, obviously this will be little c, right? What we want to find the distance between Belleville and Compton. That's the distance between here and here. So what we want to find is A, right on your paper. We want to find A. Now, when you're using the cosine rule, whatever it is you want to find, be it the size of an angle or the length of a side, that letter has to be the beginning and ending of the formula. So it has to begin with an A, right? And the formulas go like this. We always A squared and cos capital E, right? Equal here. It starts and ends with the same letter. Common letter at the beginning, capital letter at the ending. In between here, the other two letters go in. So we have B squared plus C squared, and usually it'll be minus 2 by these same two letters that they have here, B, C, right? Now, 2BC cos A is one thing here. All of these things multiplying, you have to square these two things here, and well, you have the A on the side. Now you want to substitute values. So let us see. Do we know what A is? We don't know what A is. What is B? B is 310 degrees. What is C? Kilometers, sorry. What is C? C is 90 kilometers, right? So we have B, we have C. Do we know angle A? Angle A is the 60 degrees. Everybody give me a thumbs up if you follow me up until that point. Thumbs up, everybody, if you follow me up until that point. Give my hands up if you didn't follow up until that point. Hands up if you want me to recap. No, everybody good, right? And everybody hearing. Right. So I'm going again. So A is what we don't know. That's what we're trying to find. B is 310 squared plus C is 90 squared minus 2. B is 310. C is 90 cos 60. See how easy it is to enter this information into your cosine formula, right? Real easy. Now we have to do some calculations. So I will go to my calculator and I will find what, I'll work them out in pieces, right? Look at the pieces that I'm gonna do. I'm gonna work out these two here and per answer. Then I'm gonna work out this piece here and put the answer and just bring down the cos 60 here. Right? So I'll get the answer for that and I'll go in front of this. I'll have one number for this now minus that and a squared on this side, right? That's how I'm going to do it. So let me get them values here. 310 squared plus 90 squared, right? Use your brackets when you're doing this part, right? So that's 104,200. 104,200 minus. So I'm doing 2 by 310 by 90. 55,800. Right? Cos 60. Right? So let me say she good with me up until then. Next thing I'm going to work out is this here now. Right? I'm going to do cos 60 on my calculator equals multiply by 55,800. That's going to give me 27,900. Now, you gotta pay attention to the order in which I do these things, right? Because this is what used to cause me to get this question wrong. You can't plug in all of this in the calculator and you have to understand that is this part minus this whole part here. It's two separate parts that have work out and then subtract from each other. So it had to end up to 104,200 minus this 27,900. Now I'm going to subtract these two. 104,200 minus 27,900. That's 76,300. And then the last thing I'm doing now is moving that square. And we're going to find the square root of this entire thing. I'll just write it here, right? Because I'll run out of room. Square root of that. That's 276.22. 276, we just put to one decimal place. We're in kilometers. .276.2. Well, let's say to the nearest kilometer. Forget that. Pay attention to when they write things like that, right? So to my nearest kilometer will be 276. I just write the approximation in. Everybody okay with that? Give me a thumbs up if you follow me all the way to the end of that. To get in 276. Right. You understand the order in which I do it, right? Good. Calculate to the nearest degree now the measure of A, B, C. Right? So they want us to find the angle B. Now we have three sides. Right? Because we know that this is 276 now. We could approach this two ways. We could either use, I think I would use sine rule here, right? Because we could do A sine A. And since you want to find B, we just use B sine B. A, we know it's 276. We just work out that. Capital A is 60 degrees. B is 310. And angle B is what we're trying to find. Give me a thumbs up if you agree with what I now say there. Right? Make sense to everybody? So that's what we're going with, right? So I'm going to plug my values in now. So A is 276 sine 60. B is 310. Sine B is what we want to find, right? We have to work out the measure of that. So remember I tell you where they say cross multiplying, right? So sine B by 276, right? I'm multiplying there is equal to 310 by sine 60, right? I want B. So I have to move this 276 first. And then I have to move the sine. But when I carry sine across the equal sign, it's not like the question we did before where we carry sine 30 across the equal sign. We are just moving the sine alone. So when we move the sine alone, it becomes sine inverse of all of this on the side here. This predictive drawing thing sometimes is more thumbs up if you're following me up until this point. Right? Good. So here we're doing here, right? Here we're going to enter these things on the calculator. I'm doing sine 60 first. Sine 60 equals. Then I'm multiplying by 310. Right? After that, now I'm dividing by 276. And then I'm going to take my second function, sine inverse equals. And I'll get 76, what is it? To the nearest degree. 76.5. I'll just tell you what is it again. 76.583 something. So B is going to be 77 degrees to nearest degree. My thumbs up if you're okay with that there. A hands up if you want me to recap. Yeah, no problem, Jasmine. Right. Starting from the top again, right? So we want to find angle B, which is I want a different color highlighter. We want to find this piece inside of here, right? Now, let me see what we have. We have, what color I could use, boy? We have this angle A here. We know the length of A. We know the length of B, and we want to find this angle B. So I think we could use the sine rule. A, capital A, B, capital B. We know the length of A, we know the length of B, we know angle A, and we just had to work out what B is. Right? So Jasmine, Suberi, give me a thumbs up if you with me up until there. And anybody else that needed a recap, just give me a little thumbs up. Right, everybody following me there. Good. We substitute in values now. So the A is 276. That's my A here. The capital A, which is the angle, is 60 degrees. That going in here. The B, which is our length, going on top of here. B is what we're trying to find, so we write in that here. Right? Then we have to cross multiply. The bottom here being multiplied by the top here. That's how I get in this part. And then the bottom here multiplying by the top here. That's how I get in this part. The more thumbs up if you're okay up until that point. Yeah? Good. Right. So the next thing I'm doing is I'm moving this 276 across here. So it becomes 310 multiplied by sine 60 divided by 276. Thumbs up if we got up until there. The thing is virtual thumbs or little thumb, I guess so. All right. The next thing I'm moving is the sine. Right? But when I'm moving this sine though, it's not a divide. When I change the side for the sine, it becoming sine inverse. It's different. If it had sine 30 on the side and I move the whole thing across, then I would divide. But this is not sine 30. I'm moving the word sine itself, right? Because I don't know the angle. So that's why I'm becoming sine inverse. And it'll be sine inverse everything here on this side. So I have to work out the value of this whole thing here, right, Jasmine and Zuberi? I have to work out the value of this whole thing and then find sine inverse of that. So to do this, on my calculator, I'm doing sine 60 equals, and I'll get an answer. Then I'm multiplying by 310 equals. Then I'm dividing by 276 equals. And then I'm going to take second function, sine, right? And what will happen is you'll see sine inverse come up on the screen, and then I'll hit equal. And what I will see is 76.583. And I'll put it to the nearest degree, right? So since it's 76.5, we round up to 77 degrees. The more thumbs up if you understand. Yeah? Good. All right. So next part of the question now. Determine the bearing of C from B. Remember how we talk about that? If we want the bearing of C from B, we now work out this to be how much? 76 degrees. 77 degrees, right? So I write in 77 degrees. Now I just wanted to bear in mind, right, that this angle here is 150. This is 77. This is angles around a point. Was it some of the angles around a point? Anybody? Some of the angles around a point. Is add up to be how much? Better carry.
So when you say a point,
Like a circle.
360?
360. Right? So around the point is a whole circle. So at a point, around the whole point, we have 360. So how much of them I have here? I have 150 for this little piece here and 77 for here. So I could find this missing piece here. Very good. And that will give me a bearing of C from B. Give me a thumbs up if you understand that. Right. So the bearing of C from B is going to be 360. Everybody remember we get a 150, right? That was because of the co-interior angles, what so I'd forget about. I was calling it all kind of wrong name. But I didn't forget about it. I know it's add up to 180. It's a name I couldn't remember. So that's 227. $360 minus 227, 133. Bearing of Compton from Belleville is 133 degrees. Everybody all right with that? Yeah? Nice. Good. So we're going to vectors and matrices now, right? Like I thought exact amount, boy. You're gonna make a circle back till we do our session next week. That's just enough. But I'm glad we do the older papers. The older papers sometimes is there more challenging questions. What we'll do at the next session on Saturday is we do the same thing. Break it up into relation functions, measuring geometry, trigonometry, vectors, but we do like one of the more recent years. Probably a less questions so that to have some other things in the section one that I wanted to touch on, like the statistics. So there are them frequency tables that I expect everybody to be right to the algebra. Something else I was looking at earlier today and I said I touch on. Frequency for sure. You can look for coordinate geometry and things like that, and it's easy stuff that we could rack up fast. I just wanted to make sure you're solid in this section too, as the area where everybody's give up on. All right, so let's get going again. Vectors and matrices. So the points A, B, and C have coordinates negative 2, 8, 4, 2, 0, 9. M is the midpoint in the line segment of AB, right? So that is half point, halfway through. Express each of the following in the form XY. You want OB, right? Well, OB is what we call a position vector. And position vectors, when you have to represent it in a vector form, is equal to their coordinates. Right? So vectors and coordinate geometry very similar. All you're really doing is instead of writing the stuff vertical like this or horizontal like this, you start writing them vertical. But you have two types of vectors. You have position vectors and you have free vectors. Position vectors is always start from O, your origin. And you could identify them because you always have O in them. You see like OB or something like that. When it's like that, because it's starting from the origin, when you're writing it in the vector form, it's always be the coordinates of the endpoint. The endpoint in this case is the B, 4, 2. So OB is 4, 2. All right? This is an example of what we call a free vector. It's not starting from O, the origin. It somewhere in the middle there, right? It has a starting point A and an ending point B. Now, in order to write it in vector form, what we have to do is take the ending point, which is B, and subtract from it the starting point, which is A. So it's ending point minus the starting point. Everybody understand that? My thumbs up if you understand that. So 4 minus minus 2, pay attention to your signs, right? We give me 6. And then 2 minus 8, we give me negative 6. Right? Everybody okay now? And just for knowledge sake, I'll show you how we could test the accuracy of this, right? Because since I kind of nerd in our way too. So A, let's just assume that A is, what we say up here is negative 2, 8. So I need a little more space on this side. I just say this is negative 2 here. And this is 8 up here, right? So this is the point A. And then B now is the point 4. I say this is 4. And I say somewhere here is 2. B. Everybody seeing A and B, right? A, B. So if I draw a line this way, that is the vector AB that they're talking about. Now pay attention to this, right? This vector, it going, let's look at the horizontal movement this way, right? Horizontal movement means that I'm going from left to right, right? So it are kind of going up the number line. So a movement horizontally from left to right, since we're going towards the right, right will always be considered positive, right? Means that I should get a positive movement in that direction. Correct word is displacement. Let me check how much times I will shift to get to 4. Well, I'll have to go to -1, right? So that is 1 movement, then to 0, then to 1, then to 2, then to 3, then to 4. Let me count that. 1, that is still -1, 2, 3, 4, 5, 6. See my 6 here, right? Give me a thumbs up if you see that. Right. And then the movement now on the downwards, the other part, this is my vertical movement. So we just look at going across from left to right. We're talking about vertical movement now. Either we could go down, up, or we could go up, down. In this instance, we're actually going from up, down. Agreed? Because we have 8 here, and then I'm going down to 2 here. Everybody agree that we're going down? Give me a thumbs up if you agree that we're going down. So if we're going down, right, it will be negative. A movement downwards will be negative. If it was going up, it will be positive. Let me see how much times down are going. 8 to 7, 7 to 6, 6 to 5, 5 to 4, 4 to 3, and then to 2. I don't mind it now even. So that is 1 time, 2 time, 3 time, 4 time, 5 time, 6 times. See where I get the -6 now? I move 6 down, so that's why it's negative. So you see how this making sense? Give me a thumbs up if that makes sense there. Right? So that's what vectors really is. Vectors really expressing, the correct word is displacement. Horizontal displacement versus vertical displacement. And if you have points on a coordinate, on a graph, like how this point was 2, -2, 8. And this point was 4, 2. We could use those points in order to determine the vector by taking our end point and subtracting our starting point from it. Give me a thumbs up if you understand that. Thumbs up if everybody understand what I now explained today about vectors. Right? And as a summary of what vectors is in a little short there. Cool? Right. So OM now. What is OM? They say M is the midpoint of the line segment AB. So if M is the midpoint, midpoint means what? Half, not so? It's halfway through. Give me a thumbs up if you agree with that. So half of AB, where's AB? We now work out AB to be 6, negative 6. So half of that will be what? 3, negative 3. 5 marks. That was even more than some of them other questions that we do before. Everybody right with this? Give me a thumbs up if you're okay with this 5 marks that we now get there. Everybody understand? Anybody need me to recap? Let's do our hands up instead. No, we good? Right. Using a vector method, show that AC and OB are parallel. Right? Now, for vectors to be parallel, one vector can be expressed with a scalar, meaning that, you know, like when you factorize something, you have a highest common factor that you could pull out, you could factor it there. So if A, let's say AB is equal to 2, 4, and I have another vector called CD, which is equal to 4, 8. Since CD could be represented as 2, I could factor all this 2 as a scalar, right? Because 2 by 2 will give me back the 4, 2 by 4 will give me back the 8. I could say that AB is parallel to CD. Give me a thumbs up if you understand what I now say there. Right. The thing with this is that we don't know what AC is. I don't recall working out AC. Anybody recall working out AC here? No. I know OB, but I don't know what AC is. Now, we could use the points that we have in order to work out that, because the point A, right, which is negative 2, 8, could be represented as a position vector. Remember I tell you about the position vectors? That just means that it's starting from O, the origin. O, A will be negative 2, 8, right? Position vectors will always have the same value as the ending point. So O is the origin as 0, 0, right? So it come like you're saying, if you go with the same formula before ending point, take away starting point, you'll just have negative 2, 8 minus 0. So that's why I'm returning the same thing. I could do the same thing for C2. C as a position vector, 0, 9. Will be OC, which is same 0, 9, right? Nothing to work out there. So I have two vectors here that I could use to try to work out what AC is. AC, right? Now, if I want to go from A to C, right? Start at A and go to C. When I did these two position vectors, they have a common point. They have a common point because both of them, I do them from O. That's the common point that they have, right? Everybody agree with that? Give me a thumbs up if you agree that that is a common point to both of them. So I could stay and I'm gonna draw it so you'll see it better. So remember when we had said we had A before? I just keep forgetting A is a right. So negative 2 and 8. That was A. So the position vector OA, remember O is the center here, right? Means that it will start at O and go up to A. Everybody understand that? And this vector is the vector -2 because you're going across -2 left, and then you're going up 8. So this is OA here. -2, 8. OA. Everybody understand that? Give me a thumbs up if you understand that. OA starting from O and going up to that point A. Oh, I need to know that everybody okay with that, right? And then OC now going to be starting at, it have no movement across. It is 0 to 9. This is 9 up here. 0 movement. I'm in line with 0 here on my X, right? Because this is my X, this is my Y. And I'm going up to 9. That is C. So OC is 0, 9. Tell me if you agree with that. Thumbs up if you agree with that. I want to find what AC is. Right? Now check this. If I want to go from A to C, there's an alternative route that I could go. So let's imagine that it have a bridge here and this bridge collapse. So I can't stay from A and go to C. But I could go from A down to O. And when I reach O, stay from O and go up to C. Tell me if you agree with that. My thumbs up. So it's like an alternative route now, right? I want to find AC. I don't know what AC is. It have a broken bridge there. I cannot cross and go from A to C. So my alternative is to stay from A, go down to O, and then stay from O and go up to C. Give me a thumbs up if everybody agree with that. Right. So I am actually going to write that. We are going to go from A to O, and then from O to C. Make sense? A thumbs up if it makes sense, if that makes sense there. And by doing that, I am going to achieve going from A to C. Yes? Right. So the thing is, I have OA, but I could get AO. AO is just changing the direction. And when we want to change the direction, all we have to do is write the negative of what we had originally. So negative OA is equal to this AO that I'm trying to find. So all I have to do is just multiply everything in here by a negative sign. This will become positive. This will become -8. And I'll change the direction. And that will make sense, right? Because check it. If I'm going from A down to O now, then I have to travel to the right. So this what was previously -2 would have to be positive. And then I'll be going down. I'll starting from 8 and go down to 0. And we say when we're going down, it will be negative. Right? So this is now, A will now be 2 minus 8. Give me a thumbs up if you agree with that. No thumbs up from my way? Everybody? Idal, Zuberi, Solana, Avalon, Rian, Joshua, Jamari, Christian, Carol. Christian, you good? All right, good. And then, well, I don't need to do anything with the OC, right? Because OC already is 0, 9. And all I have to do now is just add these two things together. Watch. 2 plus 0 going to give me 2. -8 plus 9, well, the 9 bigger, so I'll get +1. So AC is 2, 1. And it makes sense. Check it. If I stay from 2 and I go to 0 to reach the C, and there's a movement of 2 spaces to the right, and that's positive. Give me a thumbs up if you agree with that. Yeah, that makes sense. And if currently at A, I am in line with 8 and I go up one space, upward movement is positive 2. I move up by 1. So this vector AC is 2, 1. It makes sense with what we're looking at on the graph. You understand the relation? Now, people don't usually explain it like this, so that's why there's been a little extract. But with the diagram, and if you understand what I'm telling you, with movement to the right, movement to the left, movement up, movement down, you could see it really not difficult to relate to what it is, the answers that I get in. Agree? Give me a thumbs up if you agree with that. All right, nice. So that is our vector question. Now you tackle on our matrices question now. So I'm done with that, right? Are you okay with that? I'm moving on. So M is defined as 2P minus 3, 4, 1. Determine the value of P for which M is a singular matrix. Right? That means it's not equal to 0. Sorry. A singular matrix is where the determinant is equal to 0. A non-singular matrix is where the determinant is not equal to 0. So I write that singular matrix determinant is 0. So the determinant is when we multiply across like that. So the determinant of M will be 2P multiplied by 1 minus 4 by negative 3. That's how it's find the determinants. Is cross multiply here by here and then here by here, and you're subtracting those two values. If it is singular, it means that this is equal to 0. So 2P 1 by 1 minus 4 by negative 3 is equal to 0. If it is non-singular, determinant is not 0. These are the type of matrices that we could find the inverse of. Right? We cannot find the inverse of a singular matrix. We only find inverses of a non-singular matrix. Can't find inverse. This one cannot find inverse. Okay? So 2P by 1, we give 2P. Negative here, we give negative 12 is equal to 0. That's 2P plus 12 is equal to 0. 2P is equal to negative 12. P is equal to negative 12 over 2. P is equal to negative 6. So that's the value of P for which PM, which the matrix M is singular. Okay? Just give me a second. I need to just go over notes. All right, so we're moving on to this question. So we want to find 2A plus B, right? So 2A plus B, we're going to get 2 by 1, negative 4, 2, 3, plus B is going to be 5, negative 1, 0, 3, right? We're multiplying everything inside of here by 2. So it becomes 2, negative 8, 4, 6. Now you're adding like positions together. So for example, this 2 and this 5 will be added together to give us 7. 4 plus negative 1, well, that will work out to be 4 minus 1, that's 3. Negative 8 plus 0 will give me back the negative 8. And 6 plus 3 will give me 9. Now take your time when you're doing this and do position with position, all right? Inverse of B now. Let me just move this from here. All right. Inverse of B, we have B is 5, -103. Now to find B inverse, as you in one step, you'll have 1 over, remember that thing I tell you about the determinant? So it's the diagonals 5 by 3. Talking about these two here. Minus -1 by 0. Multiply by the adjoint. The adjoint is where we kind of rearrange this matrix B here. So these two things swap in places. The 3 coming up here, the 5 going here, and we put in a minus sign in front of the other two. So a minus in front of -1 will make it 1, and a minus in front of the 0 will make it, well, you don't have anything like -0, but 0, right? Just bear that in mind. So taking off that minus sign from there, right? I'll just write a little note on the side so you remember. So A, B, C, D, they are joint, will be D, A, minus B, minus C, right? Good. So we're going again. Let's work this out here now. So 5 by 3 going to give me 15 minus, well, anything by 0 give me 0. And we get 3105. So that's 1 over 15 by 3015. Now in these questions, when you multiply this, do not reduce it. Leave everything as is, because chances are in the next part of the question, most of the time they're going to ask you to use this B to work out some simultaneous equation, right? And you'll need it in this form in order to work it out. So you see, watch the same question. B is 5, 3, 0, -1. Then they bring it back here now. And they tell you to find the values of X, Y, K. So when you have to do a simultaneous equation with matrices, right? Let us assume that this is B, it being multiplied by X and giving us K. We want to find what X is, right? Because X is the unknown value. So if I move the B across, we do divide because this is matrices, so it becomes B inverse multiplied by K. Now we just work out what B inverse was. So XY, which is I'll label this B and I'll label this X and I'll label this K, is going to be equal to B inverse, which we just work out, which is 3 over 15, 0 over 15, which is 0, 1 over 15, and 5 over 15, multiplied by 9, 3. Right? And if you're familiar with, I need space. So I'll move this and I'll move this down. Right. So we're doing row by column. So what we will get is 3 by 15 multiplied by 9 plus 1 by 15 multiplied by 3. And then underneath here, we have 0 on 15 multiplied by 9 plus 5 on 15 multiplied by 3. Each of these is going to give us our answer for X or Y. So here what we will get. Again, don't rush to cancel out this stuff, right? Because you had to add fraction. So I will simply just do 3 by 9 is 27 over 15 plus 1 by 3 is 3 over 15. Right now, you see why it is I didn't cancel. Underneath here, 0 by 9 will still give me the same 0 over 15 plus 5 by 3 will give me 15 over 15. Now I will add because my denominators is the same. I'm making my life easy. I'll get 30 over 15 on top and 15 over 15 below. Now, we have nothing else remaining to add. I could cancel. Still run out of. So that will give me 15 into 30 is 2 and 15 into 15 is 1. So x and y x is 2 and y is 1. More thumbs up if you're okay with that. No, sir, I say no. Where it is you get lost, sir? You okay with this party? Sure, that's no problem. All right. So this is B, right? We saw B above. This will be X, this will be K. Why I'm telling you that is because I just wanted to understand that in order to find, if you're doing algebra, if I want to find X, and I will just move the B across the equal sign. But this B is not like normal algebra. I can't divide matrices, so it becomes the inverse of B. So X is really equal to B inverse multiplied by K. Now, in all of these CXC questions, now, the part before, they would have always make it work out what the B inverse was. So we had our answer for B inverse above, which was this, right? So I am simply rewriting it now. And I am multiplying that by these values here, 9 and 3. Now, when we're doing matrix multiplication, we multiply rows by columns. So it must have 2 values in this row to multiply by the 2 value in this column. Otherwise, it won't work, right? So with this top row by this column is going to give me this row here, right? But the answers that I will get will give me a 2 by 1 matrix. So I have 1 value for X, 1 value for Y. So that's why I'm adding these in the middle here. Then I will do this row by this column. So this by this by this. See it? And I'm adding those 2 brackets together. So when I solve this one here, this is going to give me 27 over 15. And I solve this one here, this is going to give me 3 over 15. I am adding these 2 things together to get 30 over 15. Similarly, 0 by 9 will give me 0. 5 by 3 will give me 15 over 5. I'm adding these things 2 together to get 15 over 15. And then when I have no more addition to do, I could cancel here. I'll get 2 and I'll get 1. So I have 2, 1. My value for X is 2. My value for Y is 1. Good? Everybody good? Give me a thumbs up if everybody good. All right, we're almost there. A little tired. All right, let's look at this one. This was June 16, I think. Because we just do Jan 16. So this is June 16. Express A B in the form XY, right? So remember this? A, B. I want to go from A to B. I'm going to have a common point in the middle, which is the O. Everybody remember that? Give me a thumbs up if you remember that. From above. Remember the question we do above? I show you to go from A to O and then O to C. So I want to go from A to B. My other option is to go from A to O and then from O to B. Remember that? Yeah? So AO is really negative OA, right? Remember that. So this is OA here. So negative 2 minus 2. And OB is 6, 1. So that will work out to be negative 2, positive 2, plus 6, 1. And that's going to give me 4, 3. So AB is the vector 4, 3. Now, thumbs up if you're okay with that. Everybody all right with that one? No? Yeah? So look at the bun. All right, we'll just wrap up this question. Let's this one alone. And then I send you all this so you can try this for this one for homework. It's just a little piece. You could finish it up in not long. Let's see if we can finish it up. All right, let go hard. AC is the next one. So to get AC, we need to go from A to O and then O to C. Always remember this, right? You're going to have a common point in the middle, right? Look at these things. All of them have the O in it. So all you need to do is just to reverse. So AO is equal to negative OA. And negative OA, as we just saw, I'm going to write it here as usually write it at the side. So for all of them, I have the value for it here one time now. So when I do it over here now, I could just copy this here. And then OC is this 10, 4. So if I add those two together, negative 2 and 10 will give me 8. 2 plus 4 will give me 6. Everybody all right with that? Jamari, Tony, Carol, Christian, Brianna, Zuberi, Avalon. Everybody, Adel, we good? Yes? So determine whether A, B, C are collinear given a reason. So a collinear means they're on the same line, right? We'll want to begin with, if you look at AB and AC. AB is 4, 3. And AC is 8, 6. You noticing anything about this? If I pull out, if I say 2 by 4, 3, that's going to give me back the same 8, 6. So AC is really 2AB. So it means that they are parallel. And AC, AB, and AC both have a common point, which is A. So collinear means that they are on the same line. So they are collinear. It's like if both of them, all of them is on the same line, A, B, and C. And this is 4, 3. And AC is just a bigger version of the same thing. It's just 8, 6. It's just larger. It's twice the size of it. It's like 2 ABs. Everybody understand what I'm saying there? Yeah, Jasmine makes sense. Tony say makes sense too. Brittany. Solana, you right to that? That makes sense there. Look, they bring back the same singular matrix again. Remember with the singular matrix, the determinant is equal to 0. So what that means is that 3 by 4 minus 2 by x is equal to 0. So 12 minus 2x is equal to 0. So negative 2x is equal to negative 12. X is equal to negative 12 divided by negative 2. X is equal to positive 6. Yeah, everybody all right with that? Yeah, all right. Pressing forward again. Matrix multiplication, they want NP, which is 4132 by 1521. We're doing rows by columns. So you have to do row 1 by column 1 and column 2. So that when you're writing this, row 1 by column 1 going here, and then row 1 by column 2 going here. So here we have row 1 by column 1. So 4 by 1 plus 1 by 2. I just did this by this. Now I'm going to do this by this. So I'm going to get 4 by 5. This 4 by this 5 now. And then this 1 by this 1 now. Everybody understand that? Give me some thumbs up if you do. Everybody saw what happened there, right? Row 1 by column 1, we putting that in the area for row 1 by column 1. And then this is row 1 by column 2. I'm still in row 1 here. This is column 1, this is column 2. Now we're going to do row 2 by column 1. So row 2 by column 1, 3 by 1 plus 2 by 2. So this was row 2, column 1. You see I'm in row 2 here, column 1 here. Then I'm going to go row 2 now, column 2. So I'm doing 3 by 5. 3 by 5 plus 2 by 1. See that? More thumbs up if everybody understand that. So I have 4 plus 2, 3 plus 4. See how easy it is? 20 plus 1, 15 plus 2. So that's 6, 7, 21, 18. NP. You good? Right. PN. Determine whether the matrix multiplication is commutative. Pn is equal to 19, 11, 11, 4. Np is equal to 6, 7, 2, 21, 18. It have no working to do here because Pn. Huh? I make a mistake. Help me. 21, 15. This one here too. 17. I see it. Thanks. Good job, Zuberi. That's because of this bracket here. Look like a tree. Good job. You good then, all right? Nice. Right, so this is not commutative because Pn is not equal to Np. Anybody know what commutative means? It means that if we change the order, we get the same answer. So matrix multiplication is not commutative, but regular multiplication. When we talk about commutativity, we're talking about this. This is commutative. Because 2 by 3 will give us 6 and 3 by 2 will give us 6. But matrix multiplication is not commutative, right? when you switch the direction in which you multiply, you don't get the same answer. Understand? All right, n inverse. I do n inverse. Where's n? 4, 1, 3, 2. There you go. N is 4, 1, 3, 2. Right. So n inverse will be equal to 1 over 4 by 2 minus 3 by 1. Multiply the 4 and 2 switching places and put a negative sign in front of the 1 and in front of the 3. Working out this, we're going to get 8 minus 3 multiplied by 2 minus 1, negative 3, 4. N inverse will be equal to 1/5 by 2, negative 1, negative 3, 4. N inverse, remember I tell you, right? Don't reduce it. It's 2 over 5, negative 3 over 5, negative 1 over 5, 4 over 5. Right? So now it'll be same thing going up on here. You see, like they bring back the n. This is the x, and we could call this k. So x is equal to n inverse by k, where x is our xy. N inverse is what we now work out there. 2/5, 3/5, negative 1/5, 4/5. And multiplying that by 1 on 2. Right? So what will you get? You get 2/5 by 1, right? This by this plus this by this now. Negative 1/5 by 2. And then underneath we do this, negative 3/5 by this 1 plus 4/5 by 2. Yeah? So that's xy now going to be 2/5. You'll get minus 2/5 here, right? Because the negative by positive will be negative. A 1 by 2 give me 2. Here we get negative 3/5 plus 4 2s are 8 over 5. So we're gonna get 2 minus 2 will give me 0. 8 minus 3 will give me 5 over 5, which should be equal to 1, 0, and 1. X is 0, y is equal to 1. Everybody all right with that? Give me a thumbs up if you're okay with that. So now we good with that one? Yeah? Nice. All right. All right. So I want to just finish up this last piece of question here. Last one here. Let's do this one time. Right? The point 2, 3, this matrix here maps 2, 3 onto the point 2 and negative 3. Right? They want us to find the values of C and D. Right? So what we would usually do is we will have So let's, which one is this? Jan 17. Right. So we will multiply what would usually happen in order to, when you're applying a transformation to a point, you'd multiply that point by the transformation. So the transformation will go on the left because according to our rules of matrices, we could only multiply if this happening. 2 by 2, 2 by 1. These two things in the middle, they have to be the same, right? So the transformation always goes first and then the point second. Now, based on what we just do with matrix multiplication, what will happen here? We will get 0, c by 2, right? And 0 by 1. And now it's going to give us our point q, right? 2, negative 3. So what we need to do is to write this out here in the sense that I'll say 2c by 2, right? Plus 0 by 1. This by this is giving me this answer here, 2. And then 0 and d by 2 by 1, so 0 by 2 plus d by 1 is giving me negative 3. Everybody okay with that so far? Multiplying row by column. Yes? So outer space, right? So that's coming up here. Should I probably write it here to begin with. Let me write it on the side. I'm going to cut it out. Right. So that will give now 2c plus 0 is equal to 2. And 0 plus d is equal to negative 3. So that's 2c is equal to 2. D is equal to negative 3. So c is equal to 2 over 2, which is 1. And well, d is equal to negative 3. Everybody agree with that? Zero by 2, d by 1. Something, something, something. 0 by 2, row by column. So something like an off here. Shouldn't be getting d is equal to negative 3. 0 by 2, d by 3. I copy something wrong. Look at here. I know that I want to know what kind of madness is that. It's 2, 3. Not 1. This is 2, 3 here. All right, I'm going to just write it over, right? Bear with me. Sorry. We understand the premise, right? What you're doing basically, you're just multiplying the transformation by your point, and then you'll just solve by what it equal to. So let's try that again. 0, D multiplied by 2 and 3. Let's do it like this first. So this by this is going to give us C by 2 plus 0 by 3. Right? And underneath I get 0 by 2 plus D by 3. This is going to work out to be 2C plus 0. Here is going to be 0 plus 3D. So this is 2C and this is 3D. Now, if we say that it maps onto this point Q, which is 2 and negative 3, it would mean, therefore, that 2C is equal to 2 and 3D is equal to negative 3. And we could solve here. C will be 2 divided by 2, which is 1. And D will be negative 3 divided by 3, which is negative 1. So C is 1 and D is negative 1. Everybody all right with that now? Determine the image of negative 5, 4 under the transformation T. So this transformation T is now C is 1, D is negative 1. And if we have the point negative 5, 4, then we do the same thing that I just described there. We do 1 by negative 5 plus 0 by 4. And then we do 0 by negative 5 plus negative 1 by 4. 1 by negative 5 is negative 5 plus 0. And then 0 by negative 5 is 0 plus negative 4. So we will get negative 5 and negative 4. So this is the image of the point negative 5, 4 under the transformation T. Describe fully the transformation T. So on the side here, I left for you some charts with some transformation matrices. So you had to learn these. So this transformation matrix that we have here corresponds to this. It is a reflection in our x-axis, right? So that's why the points, when we reflect it, we notice that you're keeping the same 2, but it changing to a negative 3 because it's reflecting in the x-axis here. This is the point 2 and this is the point 3. And we reflect in our x-axis. Then it will just come down here to be negative 3. Understand? It will still be 3 spaces away from the line, and it will still be in line with 2. Give me a thumbs up if that makes sense there. Right? So the transformation T is a reflection in the x-axis. Find a matrix that maps the point Q back onto P. So it'll just be the inverse of what we had. Right? To change it back, you had to reverse it. So if this is the matrix 1, 0, 0, minus 1 that mapped P onto Q, then we'll have to find the inverse of this matrix, which really won't be difficult. We'll just do 1 by negative 1 minus 0 by 0, right? And then you multiply it by the adjoint to switch places here. You put this to be 0 and 0 because you can't make a 0 negative. Underneath here, what you get? 1 by negative 1 will give you negative 1, right? You'll end up with 0 minus 0 by 0 is 0. So 1 minus 1 minus 0, just end up with negative 1 here by negative 1, 0, 0, 1. I just come like a multiplying negative by negative here to get more positive. These zeros will remain the same, and negative by this positive here will give more negative. So this is the matrix that will map the point back. We just do the inverse. Easy? Everybody all right with that? Thumbs up. All right, guys. All right, so